The digital space is a world of connection and opportunity. Take this moment, for example.
The web has made it possible for you to enroll in this program, where you will learn from the personal stories of developers at Meta. Isn't that exciting?
By the time you have completed this professional certificate, you can become a creator of digital experiences. Connection is evolving, and so are you.
You might not have a background in tech at all, and that's okay.
Even if you have no experience, this program can get you job ready within a single year.
So how can this professional certificate prepare you for a job at an organization like Meta?
The Back-End Developer Professional Certificate will help you build job-ready skills for a back-end development role while earning a credential from Meta.
From Meta engineers, you will learn about how they collaborate to create and test high-performance websites and applications.
You'll also discuss interesting topics with other aspiring back-end developers and complete a range of coding exercises to improve your skills.
It's important to complete all the courses in the certificate in order, as each course will build on your skills.
Although we have a recommended schedule for each course, the program is entirely self-paced, which means your time is your own to manage.
As you make your way through the courses in the certificate, you'll learn how to program in Python, which is one of the most popular programming languages in the world.
You'll also learn how to query a database and surface its data on an interface, build APIs that connect applications to one another securely,
and use the Django web framework to connect the front end and back end of your web application.
For your final project, you will create a web application with a functional integration, designed and developed with best practice back-end architecture to showcase as part of your portfolio during your job search.
You'll also be ready to collaborate with other developers, as you will have learned to use Git and GitHub for version control.
If you're hoping to operate independently or in a smaller team, not to worry. We've also got you covered when it comes to the basics of cloud computing.
In the final course, you'll prepare for the coding interview. You'll practice your interview skills, refine your resume, and tackle some common coding challenges that typically form part of technical job interviews.
Once you complete the program, you'll get access to the Meta Career Program's job board,
a job search platform that connects you with over 200 employers who have committed to sourcing talent through Meta certificate programs.
Who knows where you'll end up? Whatever the future of connection looks like, you'll be part of its creation. Let's get started. Many of the activities you do every day can be entirely performed online. You can use applications on your phone, computer, tablet, or other devices to access the web and perform tasks such as shopping, reserving hotels, and chatting with friends and work colleagues. With remote working becoming more popular, you can work, engage with your colleagues, and be productive all from the comfort of your home. All of that is possible with a combination of internet infrastructure and technologies and skilled professionals who build the apps that you use. Just to mention that when you come across the term app, it could refer to an app on your phone or to a web app that runs on a website or by some other online method. In this course, starting with Module 1, you will cover an introduction to how the web works, including an exploration of web pages, web servers, and web browsers. You will learn what each is and what their role is in bringing the internet to you. You will also get hands-on practice using core internet technologies like HTML, CSS, and JavaScript. You will learn how developers bring these technologies together and build functional and interactive websites and web applications. As you progress, you will explore some of the tools used by professional developers, and you will learn the fundamentals of coding using best practices and standards. For example, you will learn how to use the web browser's built-in developer tools and code using industry-standard software known as an Integrated Development Environment, or IDE. Professionals use IDEs to write code more efficiently. In Module 2, you will begin your coding journey with an introduction to HTML5 and CSS. You will learn the basics of each of these languages and how they complement each other to lay out and style elements on a web page. This includes text, images, and multimedia elements like video. Additionally, to make sure that your web page is accessible to everyone, you will learn how to code for web accessibility. In Module 3, you will learn how developers use frameworks and libraries. This module will focus on responsive design. You will learn how to implement the Bootstrap library so that web pages can offer a great browsing experience no matter what type of device is used. You will also learn about user interface or UI design and how to work with common UI components and position them using the flexible Bootstrap grid. Next, you'll be introduced to React, a free and open source JavaScript library that developers use to build user interfaces based on UI components. And you will then learn about the difference between static and dynamic content and the benefits of using single-page applications. And speaking of content, in Module 4, you will have an opportunity to put your new skills into practice by editing your very own biographical web page. In summary, this course provides you with an introduction to web development. It is part of a program of courses that leads you towards a career in software development. There are many videos in your course that will gradually guide you toward that goal. Watch, pause, rewind, and re-watch the videos until you are confident in your skills. Then, consolidate your knowledge by consulting the course readings and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. You're not alone in considering a career as a web developer, and the course discussion prompts enable you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and make new friends. To be successful in the course, you should try to develop a schedule for your learning regime. Ideally, commit yourself to a regular time slot and duration for your study. You have probably encountered many new technical words and terminology in this video. Don't worry if you don't fully understand all these terms right now. Everything will become clearer as you progress through the course. When you eat at a restaurant, there are often many cooks preparing different parts of your meal. Similarly, for the websites and applications you use every day, many roles are involved in delivering these projects to users. If you were to look up a list of high-paying IT jobs, web developer roles would certainly feature prominently, and with good reason. The digital world that we all live in would not be possible without developers creating, architecting, and maintaining the technology that we use every day on our devices. But it can be confusing for aspiring developers to understand some of the terminology associated with web development. Finding the right area for you will depend on a greater understanding of web developers' roles, responsibilities, and technologies. For example, suppose you are a visual person. In that case, you might want to design a stunning website that offers an excellent experience for its end users. Or, if you're more analytical, you might be interested in working with the technologies that power a high-performing e-commerce site. Likewise, if your interest is mobile devices, your passion may lie in creating the next big social media app. While job roles and titles may vary, web developer roles are usually split into front-end, back-end, and full stack. In this video, you will learn about each of these, their differences, and the skills required to gain a job in these areas. A front-end developer is someone that works on all parts of a website or web app that users will interact with. This can be anything from the style, colors, buttons, menus, or user interactions as they click, swipe, and interact with the site. The skills of a front-end developer can vary, but they will always focus on three leading technologies: HTML, CSS, and JavaScript. For example, suppose you are a front-end developer assigned the task of adding a newsletter sign-up option to the homepage of a website. In this case, you would use HTML to build the display elements, such as the input area for the user to type their email address and then the button to click to send it. You can then use CSS to position, color, and style these elements on the page. And finally, you can use JavaScript to process the activity when the user clicks the button. This could be something like checking the email address is valid and then sending that email address to the website for storage under newsletter members. While HTML and CSS skills are essential, the most critical skill is usually JavaScript. It is the powerhouse of front-end technology. This is mainly because of its versatility and the fact that it is paired with powerful libraries and frameworks such as React by Meta. These can be used to build rich user interface-driven enterprise websites and web apps that are fast, secure, and highly scalable. The salary of front-end developers are competitive and can vary based on experience. Generally, front-end developer roles will be available for junior, intermediate, and senior level professionals. As an aspiring developer, This is a great area to get started in. Entry into the job market for a junior position is possible with some fundamental demonstrations of core concepts and skills and an eye-catching sample portfolio. A back-end developer works on the parts of a website or web app that the end users don't see. These activities occur behind the scenes, particularly on the web server, in the database, or in constructing the architecture. Back-end developers are responsible for creating and maintaining functionality when users request information or when the website needs to communicate to another part of the web architecture for processing. For example, performing an account login or completing an online purchase using a credit card. A back-end developer will facilitate the interaction of the website and the content stored in the database. As a result, back-end development requires different languages, skills, and tools. While these can vary, they generally consist of knowledge relating to back-end programming language, database management systems, APIs, and web servers. Salaries are similar to front-end developers and depend on experience. Still, the salary may be higher in some instances, especially for entry and senior level positions. This is because getting started with back-end technologies requires more setup, configuration, resources, and general IT structural knowledge. This is in contrast to the front end, where you can start learning some elements using only a web browser. The road to back-end development is generally long, as you must have a proficient understanding of the needs of front-end technologies. This can include things like the inner workings of the internet, networks, and servers. It's pretty common for aspiring developers to first start with the front end and then move to the back end once they have acquired specialized knowledge. A full-stack developer is someone equally comfortable working with front-end and back-end technologies. Full-stack developers have skills and knowledge in all areas of the web development project cycle. For example, they have relevant expertise in the planning, architecture, design, development, deployment, and maintenance of the website or web app. Full-stack developer positions are generally at a more senior level. It can take some time to gain the knowledge, professional experience, and skills to become a full-stack developer. As a result, roles in this area are in high demand and are some of the best paid jobs in the IT industry.
Have you ever wondered how your app loads up so fast, or how when you keep on scrolling, the information comes back just as quick? We help to pretty much build snappy programs, build architectural solutions that can help you use your app well and efficiently. All right. My name is Grace Ebo, and I'm a backend engineer at Meta, and I help to build solutions that can help build our products at Meta at scale to run efficiently and reliably. My hope is that you get to understand just a little bit more about what a backend engineer is and the unique value that they add to the team. There are over 3 billion users on the platform, and so a question that always comes up is, how can we ensure that we're able to support all these users that are using this platform and not, let's say, bring down the site or make the programs and applications to be really slow? And so for me, that's probably one of the cool parts that I like to do is how to optimize and say, how can I make this experience to be even faster? How can I push the limits? How can I continue to make it of a more efficient and better experience for users? After I get some food and get my fuel up, I then begin with first looking through reviews. So I pretty much review my coworkers' code just to see how I can support them. Is there anything that looks good, anything that needs changes, just so that they can get their code to production? And then from there, I usually have some meetings. And these meetings usually are around the area of either updates or what are potential projects that we can be working on, then begin to code and get into my flow. I would say the most rewarding part of my day is being able to have a potential solution to something that has probably been nagging at my brain for days. At Meta, we honestly encounter some really complex problems, almost the fact that I think they're impossible sometimes. But that's the beauty of being able to really push the limits and say, can we go faster? Can we make it more snappier? Can we make it more ideal for even our client and engineers to work with? Sometimes I've had dreams about just potential code optimizations. And then it's just when I now say kind of that aha moment, it's like, this can work. This is it. And I write it down, type it in the code, and then boom, that's it. It actually works. And it's actually helping to achieve the goal that I set when I wrote it on my notebook. So from the technical side of things, I use Python, I use Java, more so depending on the project and what could kind of help me achieve my goal easier. Because definitely languages each have their pros and their cons. But what you may not always realize is that soft skills are even all the more necessary. So things like communication, how are you able to listen? And listen, not just to respond, but actually listen to understand. And when you hear different perspectives that may not agree with yours. And especially in this distributed remote world, it has become all the more necessary as well. So I work with front end engineers and full stack engineers in honestly diverse ways. So, for example, on my team in particular, we usually have a product. And then from there, we are able to just divvy it up based on different platforms and use cases. And so, as a backend engineer, I'm able to now build what is called the schema and the architecture of how we should be able to use this data. And it's a two-way street. Sometimes for client and front end engineers, we say, we actually need this data to be worded this way, or we need it to be in a different structure. So from there, I can either update, change, optimize, just to ensure that the client engineers, they're able to do their work more efficiently as well. And in the end, we want to ensure that we build a product for our users that it's well built and efficient and scalable for ultimately years to come. From your year 1 to even year 5 or year 10, there's always going to be something that you may not know. And it's always going to be an opportunity to learn something new and to continue to grow your skill set and your repository, pun intended, of different technologies and opportunities to grow and make things more optimal or more scalable at different companies. There's always going to be a need of how we can scale, of how we can make things more snappier, about how we can make things run more efficient. And it's you and the work that you're doing now that is going to be able to help power that in the future.
In this video, you will take a trip into the future to get a sneak peek at what you'll be able to create with your new set of skills. You will have the opportunity to complete this project at the end of the program using the skills that you have gained in each course. Completing this project will help you to validate the knowledge and skills you have gained. So, that's what you will be able to accomplish with your new set of skills. Pretty cool, right? And the best thing is that you'll get to showcase it for your next prospective employers. Hello and welcome. Did you ever find yourself searching for something online? How long did it take to get a response from your search? You search for something and you get a response back in no time. That's really something, isn't it? But did you ever think about how it all happens? In this video, I will guide you through the basics of how the internet works. Let's start at the beginning. You open your favorite app on your device and you're instantly connected to the world. This is all made possible because two devices connect and communicate via a wired or wireless connection, forming something called a network. You can connect multiple devices to this network, but this becomes very complicated very quickly as each device needs to connect to every other device to communicate effectively. This problem is solved by something called a network switch that connects multiple devices and allows them to communicate with each other. The network switch can connect to other network switches, and now two networks can connect. These network switches then connect to more network switches until you have something called an interconnected network. This interconnected network has another name that you might be familiar with. It's called the internet. When we use websites or video streaming services on the internet, these are provided by computers called servers. Our devices are called clients. This is known as the client-server model. The internet connects the entire world. Have you ever had a video call with someone on another continent? That video data traveled through large undersea cables connecting the world's networks, and these cables can transfer huge volumes of data per second. There are a lot more technical details that go into making the internet possible, but this is the main idea. Hopefully, this gave you the big picture of how the internet works. A server is a computer that runs applications and services, ranging from websites to instant messaging. It's called a server because it provides a service to another computer and its user, also known as the client. It's typically stored in something called a data center with hundreds or thousands of other servers, all running different services connected to the internet. There are many different systems in data centers to ensure that servers have continuous power, continuous internet connection, and are kept cool 24 hours per day. Did you know that there are data centers located all around the world? Many websites use these to allow you to access your content quickly from the data center nearest to you. The data center servers are built based on the server's purpose. For example, if the server is only to be used for storing images, it might have a lot of hard drive space, whereas a server computing complex calculations might need a fast processor and a lot of memory. This is usually referred to as the server hardware, the physical components of a server. Once the server hardware is installed in the data center, a piece of code can now run. The code that runs on the hardware is commonly known as software. One way I like to remember this is to think of hardware as something you can physically touch and is difficult to change, as you need to physically replace components. Software is soft or easy to change. You just replace the code running on the server. The services a server can run can vary, but in this video, you will learn about a type of server software known as a web server. A web server has many functions, which includes website storage and administration, data storage, security, and managing email. Another primary function is to handle something known as a web request. When you open a browser on your device and type the name of the website, it's the job of the web server to send you back to that website's content. This process is known as the request-response cycle, and you will learn more about it later. Web servers are also designed to respond to thousands of requests from clients per second. In this video, you learned about web servers and how they consist of hardware and software. You also learned that one of the primary roles of a web server is to respond to web requests from the client. You may have heard the terms web pages and websites, but what's the difference? A web page is a document that displays images, text, videos, and other content in the web browser. A website is a collection of web pages that link together. You've likely visited many websites this week. In fact, you're watching a video on one right now. Let's explore an example where you visit your favorite encyclopedia website. When you arrive at the homepage, it contains many links to different articles. Clicking on one of those links brings you to a new web page article, and that article links to even more articles on other web pages. If all these web pages have a similar address in the web browser's address bar, it can be safe to assume that they belong to the same website. However, the links on the page do not all have to link to the same website. They can also link to other websites. For example, when you visit your favorite search engine and search for a phrase, the search results are a list of links to other websites. Did you know that as I'm talking to you, thousands of websites are being launched to the internet? Every day, hundreds of thousands of websites are launched. To put things into perspective, the Great Pyramid of Giza has 2.3 million blocks of stone. So think about it. In 1 week, there are as many new web pages as stones in the Great Pyramid. With current internet speeds, it would take 3 million years to download all the web pages on the internet. And all of these billions of varied web pages rely on the same core technologies. Most people interact with websites in some form daily, but few know how a web page actually works. I mean, what's it made up of? And just how does that web page get from the web server to what you see on your screen or device? Well, let's explore that now. In its most basic form, a web page is just a text document. You can open and edit with any text editor, but developers usually use more sophisticated tools for working with web pages. If you want to work with a web page, you need to know about 3 technologies and understand how they interact. They are HTML, CSS, and JavaScript. HTML structures the content you see, CSS controls the colors and style, and JavaScript is responsible for the user interaction. As a web developer, you will work with these technologies every day and understand how they work together. I always like to imagine it like this. Think of a shop. HTML is the actual building, the structure. CSS is the interior decoration and landscaping outside, and JavaScript is just like the business, the services offered, and the people coming in and out. Let me give you a brief overview of each of these technologies now. HTML stands for Hypertext Markup Language. It works by using something called markup tags. These tags describe the content that is displayed in the browser window. This content can be things like headings, paragraphs, images, and even multimedia elements such as audio and video. The way HTML describes the content is known as markup. CSS is short for cascading style sheets and adds visual enhancements like colors and layout to the web page. This is commonly known as styling. It works by enhancing the HTML elements and telling them how to display. Have you ever noticed a friend change the color or style of their hair? Well, your friend's hair is like the HTML, and the color and style is CSS. The last technology is JavaScript, which is a programming language built into the browser. JavaScript provides web developers with tools for interactivity, data processing, control, and action. Have you ever tried to log into a website only to be told that the information you provided was incorrect, or browsed your favorite video streaming site and seen content update in real time? Well, that's JavaScript in action. JavaScript is the powerhouse of a web page. It has the ability to manipulate the content that you see on the screen as you interact with it. In fact, without JavaScript, websites would be kind of boring and very limited in terms of what you can do. Okay, you now know about the essential technologies a web page contains, but how exactly does this code get translated to display the content that you see on your screen? When a copy of that web page is sent from the web server to your browser, each line of code is processed in sequential order from first to last. As each line is interpreted, the browser creates the building blocks, which is the visual representation you see on the screen. This creation process is known as page rendering. The response from the web server must be a complete web page in order to fulfill the request to show the page in the browser. You will learn more about page rendering from the additional reading at the end of this lesson. And there you have it. You now have joined the exclusive group of developers who know how a web page works. You learned about the technologies that make up a web page and how they interact with each other. You also learned that the page is rendered by the web browser to display what the end user sees on the screen. In the time since you started watching this video, another few thousand websites launched. Every one of them is another example of modern web developers building and adding to the ever-growing internet. Are you ready to become one of them? You use a web browser every day on your devices, and you probably have one open right now watching this video. But do you really know how they work? In this video, you will learn what a web browser is and how it receives and displays content. Let's get started. A web browser, or browser for short, is a software application that you use to browse the World Wide Web. It works by sending a request to a web server and then receives a response containing the content that is to be displayed on the screen of your device. Once the browser is open on your device, there is the address bar where you input the address of the website that you want to visit. The address is commonly known as the Uniform Resource Locator, or URL for short. The URL contains the protocol, or the HTTP, the domain name, usually the name of the website, and the file path, or the path to the page that is displayed. When you make a request using this URL, the browser and server communicate using a protocol known as the Hypertext Transfer Protocol, or HTTP. Once the web browser receives the content, it displays it on the screen of your device. This exchange of information is made possible by something known as the request-response cycle. Now, let me demonstrate this using an example many of us are familiar with, searching the web. First, you open a web browser, which is a software application. Next, you type the name of your favorite search engine. The name you type contains something called a domain name. Then, when you press enter, the web browser sends a request across a network and connects to another computer on the internet called a web server. The web server is a special type of computer that allows other computers to make requests for data. The web server responds by sending a web page back to the browser. Once the browser receives all the response information, the search engine web page is made visible. The web page is a coded document that is rendered by the browser and then presented visually to you, the end user. Now that the search engine web page is loaded in the browser, you interact with that page to search for what you want to find. For example, type restaurants near me in the search bar and press the search button. Once again, the browser prepares and sends a request to the same search engine web server. This time, the request contains the added instructions to search for the phrase restaurants near me. The search engine web server processes the request by taking the keyword and using it to find the requested data. This data is stored in something called a database, which is connected to the web server. The web server then picks up that data and sends it back to the browser. When the web browser receives the full response from the web server, it again renders a visible web page with links to some restaurants, a map showing nearby locations, and more related information such as reviews, lists, and even reservations. Success, and all made possible by computers having a conversation. You have now gained an insight into how the request-response cycle works. And this web request cycle is very similar for a number of other activities we do online, be it chatting with friends, watching our favourite movie, or sharing files with our work colleagues. That is just a brief summary of how the internet works. The next time you search for something online, think of all the steps and data that gets exchanged to complete your request. Okay, so by now you know that websites and files are stored on web servers located in data centers. But what if you wanted to create your own website? Do you really need your own data center with specialized hardware and software? Thankfully, the answer is no. And developers can launch websites to the internet using something known as web hosting. Web hosting is a service where you place your website and files on the hosting company's web server. You're essentially renting this space in return for stable and secure storage. And you don't need to be a company to use a web host. Individuals can rent space too. In this video, you will learn about the different types of web hosting services that you can use for your websites and web applications. First, let me share with you some of the different hosting options available. These can include shared hosting, virtual private hosting, dedicated hosting, and cloud hosting. Let's explore each of these hosting types in a little more detail now. The cheapest form of web hosting is known as shared hosting. You pay for a location on a web server containing many web hosting accounts with shared hosting. This means that you also share the server's processing power, memory, and bandwidth with other websites that might slow your performance. This option is best for a small website with a small number of visitors. Many developers also use this as a low-cost sandbox environment to practice deploying or hosting their personal websites. Some companies offer free shared hosting, but with limitations, and often have advertisements embedded in the web pages. Sites with more considerable demands use virtual private servers, or VPS. A VPS is a virtual server with dedicated CPU, memory, and bandwidth resources. It will be running on a hardware server with other VPS instances, but as the resources are fixed per VPS instance, your website is unlikely to be impacted by the performance of other VPS instances. A VPS instance will be more expensive than shared hosting. The next option up is to use dedicated hosting. This will be a hardware server that is dedicated to you only. All hardware CPU, memory, and bandwidth resources are yours to use. Generally, this option is more expensive than a VPS hosting. The last type of web hosting is something you may have heard of. Cloud hosting and the cloud has grown in popularity over the last decade and is often mentioned in various news and services you use. With cloud hosting, your website is run in something called a cloud environment, which spans across multiple physical and virtual servers. If a physical or virtual server fails, your website will run on a different server and stay online. The main advantage of cloud hosting is that you can use as many resources as you need without hardware limitations. However, you pay based on resource use. For example, if you transfer a file from the cloud to a web browser, you'll pay for the bandwidth used for that transfer at a fractional cent cost per megabyte. While this can quickly become more expensive, it allows websites and web applications to scale their cost as popularity grows. This is how many of the major web applications operate. In this video, you learned about web hosting and the different hosting options available to individuals and companies. Soon you will build your very first website. Are you excited to get it hosted so you can share it with the world? For more information on web hosting and services, please see the additional reading at the end of this lesson. Email is a common communication method that we all know about, but before it existed, the alternative was to send mail to one another through the postal system. There is a surprising parallel between the postal system and how the computer sends and receives data across the internet every day. Let's compare how they both work. Data sent across the internet is quite an important part of our everyday lives, and it wouldn't be possible without Internet Protocol addresses, or IP addresses. A useful way to think of IP addresses is that they function much like addresses in a postal system that make it possible for packets of information to be delivered to you. And, like with the postal system, things can go wrong. But let's first go over how things work before we think about how they can go wrong. In this video, you will learn what IP addresses are and explore how computers send data across the internet. You previously learned how computers connect to each other to form networks and how these networks connect to each other to form the internet. When you send data between computers across the internet, a common way of understanding this is that the computers are the destinations that request and receive the data, and the networks are the routes that the data travels across. What makes that possible is the Internet Protocol. Version 4 and version 6 are currently the two most widely used standards of Internet Protocol. Think of that old-fashioned postal system again. When you send a letter to a friend, you need their address, otherwise they won't receive your letter. Computers work in a similar way. Every computer on a network is assigned an IP address. In Protocol version 4, an IP address contains 4 octets separated by periods or dots. For example, 192.0.2.235. In Protocol version 6, an IP address contains 8 groups of hexadecimal digits separated by a colon. When you send data across a network, you send the data as a series of messages called IP packets, also known as datagrams. At a high level, IP packets contain a header and a payload, which is the data. Think of that old-fashioned postal system again. When you send a letter, you not only include the recipient's address, but also your own address, in case a return location is needed. IP packets are the same. They include the destination IP address and source IP address. These addresses are in the header along with some additional information to help deliver the packet. And the payload contains the data of the packet and some of the other protocols, which we'll cover in a moment. Earlier, I mentioned that things can go wrong with a postal system. When sending multiple letters to a friend, it's possible they may arrive out of order. It's possible that a package will get damaged, or if you're really unlucky, a letter could get lost. These issues can happen to IP packets too. They can arrive out of order, become damaged or corrupted during transit, or be dropped or lost during transit. To solve these problems, the payload part of the packets contains other protocols too. You can think of them as another message inside the payload of the IP packet. The two most common protocols are the Transmission Control Protocol, referred to as TCP, and the User Datagram Protocol, also known as UDP. TCP can solve all three of the previously mentioned issues, but at the cost of a small delay when sending the data. This protocol is used for sending the data that must arrive correctly and in order, such as a text or image files. UDP solves the corrupt packet issue, but packets can still arrive out of order or not arrive at all. This protocol is used for sending data that can tolerate some data loss, such as voice calls or live video streaming. Both of these protocols contain payloads that contain further protocols inside of them. And there you have it. The internet uses internet protocols, much like an old-fashioned postal system. These protocols can help to make sure that data arrives in order, does not become corrupted or lost or dropped during transit. Now you're able to explain how IP addresses work and how computers send data across the internet. Have you ever noticed the lock icon beside the URL in your web browser? This means that HTTPS, the secure version of HTTP, is being used. HTTP is a core operational protocol of the World Wide Web. It is what enables your web browser to communicate with the web server that hosts a website. HTTP is the communication protocol you use whenever you browse the web. HTTP stands for Hypertext Transfer Protocol. It is a protocol used for transferring web resources such as HTML documents, images, styles, and other files. HTTP is a request-response-based protocol. A web browser or client sends an HTTP request to a server, and the web server sends the HTTP response back to the browser. Next, let's start exploring the makeup of an HTTP request. An HTTP request consists of a method, path, version, and headers. The HTTP method describes the type of action that the client wants to perform. The primary or the most commonly used HTTP methods are GET, POST, PUT, and DELETE. The GET method is used to retrieve information from the given server. The POST request is used to send data to the server. The put method updates whatever currently exists on the web server with something else, and the delete method removes the resource. The path is the representation of where the resource is stored on the web server. For example, if you wanted to request an image from a page in a website, then the URL in the address bar would need to contain the full path to that particular file on the web server, such as example.com/images/image.jpg. There are multiple versions of the HTTP protocol. I won't explore these right now, but I want you to be aware that versions 1.1 and 2.0 are the most used. Finally, there are the headers. Headers contain additional information about the request and the client that is making the request. And for certain request methods, the request will also contain a body of content that the client is sending. Now, let's cover some details about the makeup of an HTTP response. HTTP responses follow a format similar to the request format. Following the header, the response will optionally contain a message body consisting of the response content, such as the HTML document, the image file, and so forth. HTTP status codes contained within the header indicate if the HTTP request successfully completed. The code values are in the range of 100 to 599 and are grouped by purpose. The status message is a text representation of the status code. During your web browsing, have you ever encountered pages that display 404 error not found or 500 errors, server is not responding? These are HTTP status codes. I want to briefly explain to you about the status codes and their grouping. There are 5 groups of status codes. They are grouped by the first digit of the error number. Informational is grouped from 100 to 199. Successful responses are grouped from 200 to 299. Redirection message are from 300 to 399. Client error responses range from 400 to 499, and server error responses are from 500 to 599. Information responses are provisional responses sent by the server. These responses are interim, before the actual response. The most common information response is 100 continue, which indicates that the web client should continue the request or ignore the response if the request is already finished. Successful responses indicate that the request was successfully processed by the web server, with the most common success response being 200 OK. You're receiving these responses every day when you receive content successfully from a website. The meaning of OK depends on the HTTP method. If the method is GET, it means that the resource was found and is included in the body of the HTTP response. If it's POST, it means that the resource was successfully transmitted to the web server. And if it's PUT, the resource was successfully transmitted to the web server. Finally, if the method is DELETE, it means the resource was deleted. Redirection responses indicate to the web client that the requested resource has been moved to a different path. The most common response codes used are 301 moved permanently and 302 found. The difference between the redirection messages 301 and 302 is that 302 indicates a temporary redirection. The resource has been temporarily moved. When web browsers receive these responses, they will automatically submit the request for the resource at the new path. Client error responses indicate that the request contained bad syntax or content and cannot be processed by the web server. The most common codes used are 400 is used where the web browser or client submitted bad data to the web server. 401 is used to indicate that the user must log into an account before the request can be processed. 403 is used to indicate the request was valid, but that the web server is refusing to process it. This is often used to indicate that a user does not have sufficient permissions to execute an action in a web application. 404 is used to indicate that the request resource was not found on the web server. Server error responses indicate that a failure occurred on the web server while trying to process the request. The most common code used is 500 internal server error, which is a generic error status indicating that the server failed to process the request. Now, have you ever bought something online and needed to enter your credit card information? You wouldn't want someone else to get this information from the HTTP request, right? This is where HTTPS is involved. HTTPS is the secure version of HTTP. It is used for secure communication between two computers so that nobody else can see the information being sent and received. It does this by using something called encryption. We won't cover encryption right now. Like in HTTP, the requests and responses still behave in the same way and have the same content. The big difference is that before the content is sent, it is turned into a secret code. Only the other computer can turn the secret code back into its original content. If someone else was to look at the code, it wouldn't be understandable. You use HTTPS every day. This is the lock icon you see beside the URL in your web browser. Okay, before I finish, I want to leave you with a brief summary of HTTP. Firstly, it is a protocol used by web clients and web servers. It works to transfer web resources such as HTML files and is the foundation of any data exchanges on the web. Also, remember that by using HTTPS, we send the information securely. Requests are sent by the client, usually a web browser, and the server replies with responses, which may be the return of an image or an HTML page. HTTP requests have a syntax that includes method, path, versions, and headers. HTTP responses follow a similar format to the request, and HTTP status codes indicate whether the HTTP request successfully completed. The status code is a 3-digit number that corresponds with groups representing different types of results. Well, now you know how the HTTP protocol request and response cycle works. You know about its methods and the elements that make up an HTTP request. Good job. The web pages you visit every day are based on 3 core technologies: HTML, CSS, and JavaScript. Together, they enable you to create web pages and applications so you can offer any content you have seen online. In this video, I will demonstrate 2 examples you can create using these technologies. This is to help you understand how they interact with one another. Don't worry, you won't need to deal with the details of the 3 languages just yet. In the first example, I'm building a web page that displays a digital clock. It shows the hour, minutes, and seconds. The time is updated every second. I will work with 3 files, an HTML, a CSS, and a JavaScript file, and you will explore the purpose of each one of them. To create the clock element, let's first define our HTML code in a file called clock.html. The HTML code has an element that describes the content in hours, minutes, and seconds. If I only use the HTML file, the content would be shown without any style, positioning, or sizing, just simply as a display of 6 zeros representing time in the format of hours, minutes, seconds. To apply styles to the HTML element, the HTML code references a CSS file called styles.css. The web browser retrieves the styles.css file and processes it. The CSS code provides styling for the clock. It tells the browser the position, size, color, background, and font type and size of each element on the screen. With that information, the browser updates the content, and the sequence of zeros and colons now display a digital clock. Finally, we need to ensure the clock updates with the correct time. This is where JavaScript comes in. The HTML references a JavaScript file called clock.js. The browser will retrieve clock.js and process it. The JavaScript file contains code that every second updates the content of the hour, minute, and second elements. With the 3 files created and linked together, your clock is fully functional. The clock example demonstrates JavaScript dynamically updating content. JavaScript can also be used for interaction. The next example demonstrates how JavaScript can be used interactively. It's a web page that plays a video. Below the video, there is a button that plays or pauses the video. The button contains a play icon. My HTML page describes the content, which is the video element and the play button element. The HTML code references a CSS file that the browser retrieves. It applies the styling to the video and button. The code in the HTML file also references a JavaScript file. The browser will retrieve the videoplayer.js file and process it. In our example, the code in the JavaScript file performs 4 actions. Firstly, it registers a listener on the button that will execute some code when the button is clicked. The second function is that when the code runs, it checks the current state of the video. The result of that check is, if the video is currently stopped, it begins playing the video and changes the button's icon to a stop icon. Or, if the video is currently playing, it stops playing the video and changes the button's icon to a play icon. Using the 3 files, you create a fully interactive video player. A summary of your functioning video player application is, When the user first sees the page, the video will be stopped by default. When they click the play button, the button will change to a stop icon and the video will begin playing. When they click the button again, it will change back to a play button and the video will stop playing. I hope those examples give you an idea of how the three core files link and work together. In both the clock and video examples, the HTML file referenced the CSS and the JavaScript files. The CSS file is called on to format and style your application, and the code in the JavaScript file implements the core functions of the app and user interactivity. When you're doing something online, you are likely to encounter web pages, websites, and web applications. But how do they differ? As a developer, how do you decide which one to create? Let's explore the main features of each one. A typical web page is one single page that consists of HTML, CSS, and JavaScript. It displays images, text, videos, and other content in the web browser. If a web page is one single page, then a website is a collection of web pages that link together under one domain name. You've likely visited many websites this week. You know when you visit your favorite encyclopedia website and the homepage has a lot of links to different articles. Clicking on one of those links brings you to an article on a new web page. And that article links to more articles on other web pages. Well, since all of these web pages exist under the same domain name, they are a website. The technical term for a link you click on is a hyperlink. This is because they link to hypertext content. Remember that HTML is hypertext, markup language. However, links themselves don't have to link to the same website. They can also link to other websites. For example, when you go to your favorite search engine and search for a phrase, the search results are a list of links to other websites. You'll explore more about hyperlinks later. By now, you should probably know the difference between a web page and a website. But what about a web application? This is where the definitions get a little more blurred. The terms website and web application are often used interchangeably. The key difference between a website and web application is the level of interactivity and dynamic content. The easy way to remember this is that a website is more informative and a web application is more interactive. Think of ordering food online. Let's say you would like to order some food and you go to your favorite site. The browser then displays a web page. You select some food from the menu and submit your order. Compare this to, for example, a company website that displays information about themselves and the services they provide. In the food ordering example, the content displayed is specific to your user account and location. The web application displays content based on the user's input and interaction. Whereas with the company website, the user simply views the content, and this content is the same for everyone who visits the website. You should now be able to distinguish between web pages, websites, and web applications. You know that web pages at a particular domain make up a website, and that the key difference between websites and web applications is the level of interactivity and dynamic content. If a car breaks down, you can open the hood to examine the engine and to find out what's gone wrong. As a developer, if your front end isn't working as expected, you can also open the hood to check what's going wrong. In fact, it's not just your own code that you can investigate. How about viewing other people's code? By the end of this video, you'll be able to access and make use of common web browser developer tools. Most web browsers come equipped with a set of developer tools that allow developers to inspect their HTML, CSS, and JavaScript code. Also, to trace HTTP requests to the web server, investigate performance issues, and review web page security. Let's find out more by exploring the homepage of the Little Lemon Cafe. To begin, I've just opened the Little Lemon Cafe's web page on my Chrome browser. On the homepage, I can view their menu, but I want to explore the HTML structure of this menu. To do that, I need to open the developer tools. To open the developer tools in Chrome, press the F12 key on your keyboard for PC or Command-Option-J on Mac. Alternatively, you can right-click on the web page and select Inspect. There are various tabs on the top row of developer tools that provide different functionality. In this video, I'll give you a high-level explanation of some of the most used tools. First, let's open the Console tab. This tab outputs JavaScript logs and errors from your web application. The Sources tab shows all content resolved for the current page. It includes HTML, CSS, JavaScript images, and videos. With the Network tab, you can inspect the timeline and details of HTTP requests and responses for the web page. The Performance tab shows what the web browser is doing over time. It is useful if your web application is running slow because you can pinpoint the functions that are taking the most time. The Memory tab displays the parts of your code that are consuming the most resources. Finally, let's check the most used tab, the Elements tab. You can use this tab to inspect the document's HTML elements and their properties. For example, when I hover over an element in the Elements tab, it highlights that element in the browser pane. On the right side of the panel, there are tabs for inspecting the details of the elements further. This panel shows us what CSS is applied to an element and the result of the element displayed in the browser. You will explore these details in a later lesson. For now, you just need to know that if you click on an HTML element, then the information for that element will appear in the tab. Now, I'm going to demonstrate a fun trick. If you double-click the HTML, you can edit it in the web browser. For example, if I select the R menu body element, then I can change the first item in the menu from chicken burger to turkey burger. This doesn't change the content on the web server. It only updates it for me while the web page is open. If I open the web page again, it will reset. The web browser developer tools are a valuable part of your development toolkit to help you investigate and diagnose problems. And you now know how to access and make use of them. Great work. You are developing solutions, but you need to save some time and build faster. What if some of your build problems have already been solved for you? Well, it's true. Someone has already figured out many key development processes, and they are contained in frameworks and libraries that are used every day in software development. So, what exactly are frameworks and libraries? Let's say you are not a developer, but instead you work as a carpenter. You make chairs and sell them online. As a carpenter, you don't design a new hammer for every chair you make. It makes much more sense to use an existing hammer. But of course you are a developer. As such, it's important for you to know that to speed up development, developers use already developed frameworks and libraries in their application development. These might be open source, meaning that the source code is freely available for anyone to modify and build from. There are thousands of open source libraries and frameworks available, or they might be proprietary, ones that are licensed or developed internally. Many developers use the terms framework and library interchangeably. So, what's the difference between them? Libraries are reusable pieces of code that can be used by your application. They are purpose-built to provide a specific functionality. To give a more technical example, you're building a small e-commerce website. When a user wants to register, they need to provide their email address. Email addresses, while easy to read, can be complicated to validate. In fact, email addresses are defined across several technical specifications. That's a lot of reading just to validate an email. Even if you do read through all the specifications, there's no point in spending hours or even days implementing their standards because you have access to so many readily available libraries to validate email addresses. It is for specific functionality, like validating an email address, that libraries are useful. A developer simply uses the library to access the functionality they require, and as a result, they can have more time to continue focusing on the development of their application. Frameworks, on the other hand, provide a structure for developers to build with. Consider this in the context of our carpenter analogy. As a carpenter, you create a lot of different chairs. Therefore, there would be a blueprint for each chair to speed up building them. You can decide the type of wood to use, but the dimensions and style of the chair are always the same. Frameworks act as a structure where the developer provides their own code that the framework interacts with. For example, there are many frameworks for developing web applications. These frameworks handle functionality that is common to all web applications, such as receiving HTTP requests and sending HTTP responses. The developer then adds their own code that implements the functionality of the web application. For instance, with the e-commerce website example, a framework would handle receiving HTTP requests. The developer would implement code that processes the request and returns a response from which the framework would send a response over HTTP. Now, let's compare how the frameworks relate to libraries. Most frameworks use many libraries. The libraries that the framework uses can be used by your application. If you wish, your application can also use other libraries. You also need to consider when to use a framework and when to use a library. Frameworks are considered opinionated, and libraries are considered unopinionated. This is defined as the degree of freedom available to the developer to choose how to code a feature. The opinionatedness will vary between frameworks, but by definition, they will always be more opinionated than a library. Frameworks define the libraries, flow, and control of an application. Whereas with libraries, those are left to the developer to decide. As with everything, there are advantages and disadvantages to both. Frameworks are a great way to reduce development time and to enforce a structure on how code is written. They have many best practices already in place and contain most of what is needed to develop an application. However, sometimes you may find that the way you need to code something doesn't fit into the structure of the framework. Other times, you may find that some of the libraries the framework uses may conflict with a library that you are required to use and cause compatibility issues. If an application is built without a framework, the developer will need to decide on the set of libraries they wish to use to achieve the functionality they must deliver. They will also need to take care that the selected libraries can work together. The upside to this is that they can replace libraries as needed. For example, if a new, better library is released, the developer can replace the usage of the old library. This is much easier than replacing a framework. Frameworks and libraries give you the opportunity to reuse existing web app functions. This can result in faster development, fewer errors, and more time for you to spend on the essential features of your application. Instead of reinventing the wheel, you can use frameworks and libraries that are designed specifically to help your web app development processes. Every day, you access information on your phone, like reading the news, purchasing goods and services, or communicating with friends over social media. But how is all this information transferred behind the scenes? Your favorite websites and apps probably use APIs, and as a web developer, you will discover that APIs are developer-friendly, easily accessible, and a very valuable and useful development tool. API is the acronym for Application Programming Interface. An API is a set of functions and procedures for creating applications that access the features or data of an operating system, application, or other service. If this still sounds a bit vague, just remember that the term API is intentionally open to many applications and use cases. As a web developer, a lot of the day-to-day job involves working with APIs. Some common APIs that web developers work with include Browser API, REST API, and Sensor-based API. Over the next few minutes, you'll explore each of these API types and review a few specific examples. To begin with, here's a brief outline of how APIs function. In software development, APIs are often the bridge between different components or systems. This earns them names like gateway or middleware. The term is used widely to represent many different tools and systems. Let's consider some examples of different API use cases. One common type of API is browser or web APIs, which are built into the browser itself. They extend the functionality of the browser by adding new services and are designed to simplify complex functions and provide easy syntax for building advanced features. A good example is the DOM API. The DOM API turns the HTML document into a tree of nodes that are represented as JavaScript objects. Another example is the geolocation API that returns coordinates of where the browser is located. There are also other APIs available for fetching data, known as Fetch API, drawing graphics or Canvas API, keeping history or History API, and client-side storage, also known as Web Storage API. Another critical type of API for web development is the RESTful or REST API. This kind of API provides data for popular web and mobile apps. These are also called web servers. Let's explore REST in a bit more detail. REST, or Representational State Transfer, is a set of principles that help build highly efficient APIs. One of the main responsibilities of these kinds of APIs is sending and receiving data to and from a centralized database. We can query our own REST API or third-party ones. One last type of API that you might encounter as a web developer is a sensor-based API. This is what the Internet of Things, also known as IoT, is based on. These are actual physical sensors that are interconnected with each other. The sensors can communicate through API and track and respond to physical data. Some examples are Philips Hue smart lights and NodeBots. That's a lot of APIs to think about. Fortunately, for web developers, the most common data API is a RESTful API, which, as you've learned, is a web server that provides responses to requests. These API web servers are designed to provide the data backbone for a web client like a web page or mobile app. This means that these APIs must be able to accomplish things like getting data, or get, creating data, also referred to as post, updating data, or put, and deleting data, or delete. APIs use REST principles and good design practices to create discoverable interfaces. This helps us get the exact response expected. But exactly how do they work? Here's a closer description of their activity. These APIs use endpoints to specify how different resources can be accessed. The endpoint is built into the URL when accessing the API. Once the endpoint is hit, the API performs whatever server-side processing is needed to build the response. Two common forms of response are full web pages, a data form based on JavaScript called JSON. In this video, you explored some APIs, and as a web developer, you will frequently work with many different types of APIs. You will often use APIs to extend the abilities of systems or to act as a bridge between different components. Think of a group of construction workers. Every worker has a toolbox that helps them get their job done. As a developer, you'll also use many tools. One of the main tools in your toolbox is the Integrated Development Environment, or IDE. By the end of this video, you'll be able to identify an IDE and explain the benefits of using an IDE during development. An Integrated Development Environment, or IDE, is software for building applications. An IDE is just like a text editor, except instead of writing documents, you're writing code. There are many IDEs available. Some are specific to one programming language, while others support many languages in one IDE. Let's explore some common IDE features. Here I'm working within an IDE. First, let's cover syntax highlighting. To improve readability for developers, IDEs have syntax highlighting. What this means is that special keywords of the programming language are highlighted in different colors so that the developer can quickly differentiate these keywords from other text. For example, if you're writing JavaScript code without syntax highlighting, it could be harder to identify keywords from other text. With syntax highlighting, that gets much easier because the JavaScript keywords and variables are colored differently. Now, let's explore error highlighting. Just like checking spelling in a text document, IDEs can highlight mistakes you make in your programming code. For example, if I delete the equal symbol where it's needed, my IDE will highlight the error. Another feature of IDEs is autocomplete. When you're typing a message on your phone, it suggests words as you type. An IDE's autocomplete is a similar feature. Since programming languages have special keywords, IDEs can offer suggestions to autocomplete words as you start typing them. Additionally, another feature called IntelliSense can make IDEs very smart and even able to understand your code. They can detect variables and functions and offer them as suggestions during autocomplete. For example, if I have a JavaScript function named myFunction defined at the top of a JavaScript file, then as soon as I start typing the letter M, my IDE suggests this function as an autocompletion. Then there is refactoring. Since IDEs understand your code, they can help you if you need to change it. To demonstrate how refactoring works, let's continue with the myFunction function that I defined a moment ago. In the code, the function is then called multiple times. It can also be called in the code of other files too. But what if you need to rename this function? You would need to rename it in every file that uses the function, ensuring that you update those files to use the new name. This process is known as refactoring, changing the structure of the code without changing the functionality. Doing this manually is very time-consuming and prone to error. If you mistype the new function name in one place, the application will break. Since the IDE understands your code, it can assist with refactoring and automatically update the function name across all files. That saves a lot of time. Let's rename our function now. I just right-click on the function and select Rename Symbol. Then I change it from my function to our function. The IDE then updates all references of that function name. IDEs come with a lot of other features to help investigate bugs and collaborate with other developers. Many even allow you to extend their functionality using plugins and extensions, but that's beyond the scope of this lesson. You have explored some features of IDEs in this video. You now know how IDEs operate as part of a developer's toolbox to write code more effectively. Well done. You've reached the end of this module on web development. Over the course of this module, you've explored the basics of how the web works and familiarized yourself with key concepts in core internet technologies. Let's recap the key skills that you gained along the way. You started the module with an overview of how the web works and explored the basics of web pages, web servers, and web browsers. In terms of web pages, you should now be able to differentiate between a website and a web page by outlining the key elements of each, outline the purpose of HTML and CSS, and provide an explanation of how they work, and identify the benefits that JavaScript provides to a web page, like interactivity and data processing. You've also explored the basics of web servers and should be able to explain how a data center provides storage and power for web servers, differentiate between the key functions of web server hardware and software, and outline how a web server handles requests through HTTP or Hypertext Transfer Protocol. And you explored the third key technology of the web, which is web browsers. Following this exploration, you should now be able to explain what a web browser is, describe how a web browser receives content from a web server and displays it for users, and outline the request-response cycle. After your study of how the web works, you investigated core internet technologies. You should now be able to explain the concept of IP addresses and how they facilitate the transfer of data across the internet, demonstrate an understanding of how HTTP functions and identify common HTTP methods, and outline how HTML, CSS, and JavaScript interact with one another to generate web pages. Differentiate between a web page, website, and web app. Identify the front end and back end of a web app, and list common web browser developer tools. And finally, you should be able to demonstrate an understanding of libraries and frameworks, along with their advantages and disadvantages. Identify an application programming interface, or API, and explain how it's utilized in application development, and explain the purpose and benefits of an IDE, or integrated development environment. Now that you have completed this module, you should be able to demonstrate your knowledge of the basic concepts of how the web works, and you've also demonstrated your understanding of core internet technologies. You've made a great start on your learning journey. Excellent work. When a team of builders begin constructing a building, one of their key tasks is to assemble the frame. It doesn't matter what kind of building it is. It always starts with a frame of beams and rafters. Once in place, the frame guides the rest of the construction. If you compare a building with a web page, an HTML document is a lot like the frame. It's a basic structure assembled with different components such as tags and elements. In this video, you will learn about HTML documents and the difference between HTML tags and elements. To begin, let me tell you a short story about where it all started. Sir Tim Berners-Lee, a physicist, often thought about how he and his colleagues from around the world would share information. You were so used to browsing information online that it might seem a silly thing to ponder about. Actually, that question was very relevant at the time and started the development of HTML. Would you like to explore the very first web page? I know just where to find it. The first web page was created in 1989 by Sir Tim Berners-Lee. He worked at the European Organisation for Nuclear Research, or CERN, and originally proposed HTML. The first version of HTML was released in 1991, along with the first web browser and web server. HTML stands for Hypertext Markup Language. But what does that mean exactly? Hypertext is text which contains links to other text. Markup refers to tags and elements used within a document. For now, let's just focus on some of the basics of HTML. HTML is simply a text file with a specific structure that consists of elements and tags. Also take note that HTML files usually have a .html suffix. For instance, when you visit a website, the first page that is returned to the browser is often called index.html. Now, let's explore what HTML tags and elements are. Each HTML element consists of an opening tag enclosed in angle brackets. For example, to create a paragraph, you type a left angle bracket, the letter P for paragraph, and then a right angle bracket. Most elements are paired with a closing tag, which has a / after the left angle bracket. For example, you close a paragraph element with a left angle bracket, a /, the letter P, and a right angle bracket. HTML elements usually have some content inside them. For example, between the opening and closing tags of a paragraph, you add the text of the paragraph you want to write. HTML elements can also contain other elements. For example, you can add an italics element inside a paragraph element to make text appear in italics. But elements can also be empty or self-closing, meaning they do not have a closing HTML tag. One example of a self-closing element is the line break tag. You can add a line break tag in a paragraph tag to move content to the following line by typing left angle bracket, the letters BR, then right angle bracket. At the end of a self-closing tag, you simply add a right angle bracket, but you can also close the right angle bracket by typing a / right before it. Now that you know what elements and tags are, you will explore what HTML standards are. The rules and structure for elements and tags are known as the HTML specification. The HTML specification is maintained by the World Wide Web Consortium, or W3C as it is commonly known. Whenever the HTML specification changes, a new version of HTML is standardized. The current version is HTML5. So to summarize, HTML elements with their opening and closing tags in angle brackets build up an HTML document. These elements form the structure of a web page and describe to the web browser what to display. For example, the browser reads an HTML page that has an image tag to display an image file called icon.png. Next, it reads a p tag to display a paragraph under that image. But the browser reads the HTML document and displays the web page to the user in a very basic format. Now, if you want to tell the browser how to display the web page, you should use CSS. You will learn more about CSS in this course. By now, you have learned how HTML tags are used to create elements that build the structure of a web page. You will have an opportunity to explore HTML in action in this course.
In this video, I will guide you through the blueprint of an HTML document. I will create a very simple web page for a restaurant called Little Lemon. The great thing about HTML documents is that you don't need the web to view them. Yes, they don't have to be hosted on a web server for you to view them in your web browser. You can save HTML files on your computer and view them locally with your web browser, almost like eating takeaways at home. So by the end of this video, you'll be able to identify the structure of an HTML document and create a basic web page. To create an HTML file in Visual Studio Code, I right-click in the Explorer panel and select New File, name it index.html. By now, you know that HTML documents are made up of elements and tags. But before I can add elements or tags, I first need to create the standard HTML structure, which starts with the doctype declaration tag. This notifies the web browser that it is an HTML document. Next, I create the HTML tag, which is also known as the HTML root element. And inside the HTML tag, I add the two main elements, the head and the body elements. It's important to note that nothing inside the head element is displayed as a web page in the web browser. In the head section, you add information or metadata about the HTML document. It is not part of the content of the web page. For example, inside the head tag, you always create the title element. This is the title that is displayed in the web browser tab. I can also link to CSS files and define meta tags in the head section. Meta tags can, for instance, specify the description of the web page, keywords for search engines, and the author of the web page. Next up, I add the content of the web page inside the body tag. The body can contain elements such as headings, paragraphs, images, and videos. Okay, let me start by adding a main heading on the web page by using the h1 tag. Inside the h1 tag, I type the heading Our Menu. That's good. Now I need to start creating my menu. I want to add 2 items, so I add 2 subheadings. For this, I use the h2 tag. The menu items in the subheading are falafel and pasta salad. But first, I need to save the file by pressing the keys Ctrl and S, or if you're on a Mac, Command and S. Now I right-click on the index.html file in the Explorer panel and select Reveal in File Explorer. If you're not using the Windows operating system, this may be called Reveal in Finder or Reveal in File Browser. Now the file browser opens and lists the file. I double click on the index.html file and it opens in the web browser. Great, it's all here. The title that displays in the browser tab matches the title that I added to the head section. And the content is displayed in the browser window, but it is still a bit empty. I go back to Visual Studio Code and add a short description for each dish. I do this by adding the paragraph tag below each subheading H2. Let's imagine a nice falafel. I type chickpea, herbs and spices. What goes in a pasta salad again? Lettuce, vegetables and mozzarella. Yummy. I save the file to update the changes and open it in my web browser again. There you go. Now the ingredients are also included in the menu. Some of the best websites are websites about food. Whenever you need some inspiration, search for food website ideas online. You'll be fascinated. Now that you know some basic HTML tags, try to identify where they were used in those websites. There are many HTML tags that you can use in your web pages, but you are now familiar with a few elementary ones, and I encourage you to start practicing with them. Best of luck. By now, you should know how to build a basic web page, but how do you build a website? Remember, websites consist of multiple web pages linked together. To link pages together, you use the anchor tag. Anchor tags create hyperlinks or links as they are commonly known. In this video, you will learn how to link different web pages together to create your own website. In my project folder, I now create a second web page for Little Lemon that will contain the address of the restaurant. I right-click in the Explorer panel to create a new file and name it location.html. I use the same file structure created in my index file, but add new content. I add a new H1 tag for the heading and type our location. Next, I add a paragraph tag and insert the address, 123 Home Road, Main District, Capital City. I press Ctrl and S to save the file or Command and S on a Mac. Now that my new file with the restaurant location is created, let's navigate back to the index.html file to add a link from there to the location.html file. Below the last paragraph tag, I add the anchor or A tag, followed by the href attribute or hypertext reference. I type the file name, location.html, so that my index.html file will link to it. Within an A tag, I can also add a descriptive text that is displayed as the link name on my webpage. So I type our location. The text our location will now display on the web page in the browser as a clickable link. Let's test if it works. I save the file to update it with the changes and open it in my browser by right-clicking on the index.html and selecting Reveal in File Explorer. If you're not on Windows, this may be called Reveal in Finder or Reveal in File Browser. Then I double-click on the index file. The words our location are displayed in blue in the web browser. Success! If I click on the blue link, the browser opens the location.html file. You can now link different HTML files together to create your website. Best of luck! A picture is worth 1,000 words, as they say. And I think you agree that a website without pictures wouldn't provide a very good user experience, especially websites about food. My example website about Little Lemon could certainly use a few images. In this video, you will learn how to add images to HTML documents using the image or IMG tag as it's commonly known. I have two image files in my project folder, one named falafel.jpg and another named salad.jpg. Similar to what I did with document links, I have to specify the link to the image file in the image tag. Images are not inserted into web pages. Instead, we use image tags in HTML to link to image files. The image tag then creates a placeholder for the image on the web page. To add the image tag, I type img, and inside it, I add the src attribute or source attribute as it is known. I type falafel.jpg as a source for one image, and salad.jpg for the other image. Let's save the file and open it in the web browser. The images are displayed, but they are way too big. Luckily, there are several ways to set the size of an image. But in this video, I will just demonstrate how to do this in HTML. Right after the source link in the image tag, you can specify the dimensions of an image. I first add the width attribute and set it to 240 pixels. Then I add the height attribute and set it to 135 pixels. I'll set the other image to the same dimensions. Let's save and view it in the browser again. Much better. The images are smaller. But there is one important attribute that you should always include with image tags. It is good practice to add a short description for images. It helps to improve accessibility for people using assistive technologies, and it can also improve search engine rankings. You can add image descriptions with the alternative text attribute, also known as the alt attribute. Still within the image tag, after the dimension attributes, you can add the alt attribute. I will type a short description, a falafel, and for the other image, I will add a pasta salad. I will save the HTML file again and open it in the web browser. The alt text is not displayed anywhere on the site, but will be read by assistive technologies such as a screen reader. Screen readers and other accessibility tools use the alt attribute to provide information to their users. Now you know how to add images to websites with the image tag. My website for Little Lemon is coming on well, but some key information is still missing: the prices. The best way to add information like a price list is by using an HTML table. You might be familiar with columns and rows in spreadsheet software. HTML tables look similar and allow you to neatly organize content in rows and columns. Websites almost always have information that needs to be organized in a way that makes it quick and easy to read. For example, the schedule of an event, available sizes of clothing items, or the specs of a camera. In this video, I will demonstrate how to create a simple table for the prices of Little Lemon. I want to add the table with the prices to the bottom of the index.html page, so I already have it open. Still within the body element, below the anchor element, I add the table tag. Inside of it, I add two table row tags, or TR tags, as they are commonly referred to. This will create a row for each of the dishes. Now I need to add table data tags, or TD tags, so I can include the prices. Table data tags define the contents of table cells, so I need to add two of those inside each row. One for the dish name and one for its price. In the first row, I type falafel inside the first table data tag. And in the second table data tag, I add the price. Let's say $10. I do the same with the second row. I type pasta salad inside the first table data tag and the price of $12 in the second table data tag. Now I will save the file and open it in my web browser. Great, the prices display at the bottom of the web page. The table is not displayed like a regular table at the moment, but I will style it soon. To make it more clear for my users, I'm going to add headers to the columns now. To do this, I add a new row to the top of the table with the new row tag, and then use the table header tag, or TH tag, for the heading cells. So I need to add two table header tags. I type dish in the first column's heading and price in the second heading. I save the HTML and refresh it again to check the update in the browser. Yes, the page layout is now better. The information is presented much clearer now that the columns have headings, but it is not displayed like a table yet. I will add a bit of CSS to improve the styling of the table. Don't worry about the details of that just yet. But I would like to add a little bit of magic now to get you excited about styling. I would do this by adding a style tag. I will add a 1 pixel border around the table. Let's save the file again and open it in the browser. Now the table has a border around all the cells. This is just a quick method of styling a table. Later, you will learn how to do this using best practices with CSS. Congratulations, you now know how to add tables to HTML files. I use tables extensively, and I'm sure you will too.
Today, you can order almost anything directly to your home. But did you know that one of the functionalities that makes online shopping possible is HTML forms? Without them, you would not be able to enter your credit card details during checkout. But forms are not limited to e-commerce. You can use forms practically every day on the internet. When you log into your favorite website, you do it using a form. In this video, I'll take you through the steps to create a form and introduce you to a few different input types. But first, let's briefly explore how forms work. To put it simply, when a user enters data on a website, an HTML form submits an HTTP request containing the data to the server. But how do you create a form in the first place? You define forms with the HTML form tags. Forms also have an optional form attribute called action. Action specifies the URL or path that the form should submit the request to. When the action attribute is not specified, it submits the request to the same path as the current web page. There is also the form method. With the form method, you can specify the HTTP method to use for the HTTP request. There are two HTTP methods to submit the form data, GET and POST. Remember, the GET HTTP method retrieves information from the server. The POST HTTP method sends data to the server. When a user submits a form, one of these HTTP methods is used. We'll explore how this is done on a later course. Now, let's explore how to add fields that the user can enter data into. First, let's add a simple text field. For example, a username field. The fields in a form are specified by input tags. Note that the input tag does not need a closing tag, but if I want to, I could close the tag by adding a / before the end of the input tag. When I use the text input type, it displays a text field on the web page. But a text box on its own isn't very user-friendly, so I will now add a label above it. By adding the label tag, the form will now display the word username above the input field. Next, let's add a password field. In this case, I won't use the text input type since I don't want the password to be visible. HTML has an input type specific for passwords that will mask the user's input data. The username will be visible and the password will be masked. Finally, I need to add a button so that the user can submit the form. So I use the input type submit. When the user clicks the submit button, the HTTP request containing the form content will be sent to the web server. In summary, you use the form tag at the start of a form, whereafter you indicate the method that should be used. You can create labels for input types with the label tag. You use the text input type for a text input like a username. For a password, you use the password input type. To add a submit button to a form, you use the submit input type. There are many different input types available. For example, you can add checkboxes to a form. To do this, you use the checkbox input type. You use the name and value attributes to configure how the data is sent to the server. Each box can be checked or unchecked. You'll explore this in more depth in a later course. Radio buttons, on the other hand, are like checkboxes, except only one button can be checked in the group. Checking one radio button will uncheck all the other radio buttons. There are also other types of inputs such as the number, email, and file upload types. However, some input fields do not use the input tags. For instance, the multi-line text field. The text input type that I showed you earlier is only for single-line text content. To allow users to enter multiple lines of text, I need to use the text area tag instead of text input type. Another type of input that does not use the input tag is a drop-down list which contains items that the user can select. This time, you use the select tag, and for the items on the list, you use option tags. You now know how HTML forms work and the different input types developers use. You covered form tags such as text, password, checkbox, radio, text area, and select. I can't imagine my life without online shopping. Next time you order something online, notice all the types of input the form includes and how you as a user interact with it. You might notice that the user experience of some forms is better than others. I am sure that you are now able to choose appropriate input types for the forms that you create. Imagine your favorite social media site. If it was just an HTML document, users would be able to scroll the page, look at pictures and read text, but they wouldn't be able to log in, like posts, or get notifications for new messages. In order to allow users to do these things, they need to be able to interact with objects on the page, such as the reaction icons or the comment button. Or, let me put it differently. An HTML document must be represented in a certain way so that JavaScript code can query and update it. To do this, we use the document object model. In this video, I will unpack what the DOM is, how it is created, and how JavaScript interacts with the DOM to make sites dynamic. When your web browser receives an HTML page, it constructs a DOM to represent it. DOM stands for Document Object Model, and it is simply a tree structure or model of the objects in your HTML file. To understand the DOM, I want you to think of a simple HTML page. Remember that an HTML document has opening and closing tags for the document and the head, and inside the head tags you have title tags. Then you have the body, and inside the body there might be elements such as div tags. Okay, now let me guide you through how a DOM would be generated. The DOM has a series of objects, each representing a single HTML element. At the root of the DOM is the HTML object, and it contains the head and body object. From there, the head object houses the title object, and the title object contains its text object. The body object contains the two div objects. The first div houses the heading 1 object, which again houses its text object. The second div object contains the paragraph object, which contains its text object. In summary, all the elements in the HTML file are represented as objects in the document object model. I just took you through a very simple web page. Web pages typically have hundreds of elements. Can you imagine how complex the DOM of a highly interactive modern web page is? You as a developer can use JavaScript to access and modify the DOM to make your web pages dynamic. In fact, in a later course, you will learn how to access and modify the structure of the DOM and its elements in different ways. Now that you know what the DOM is and how it is referenced, let me briefly explain common DOM and JavaScript uses. For each element, you can access the HTML attributes and content. This means you can update the existing content that is displayed in the web browser. For instance, you could write some JavaScript to update the seconds, minutes, and hours of a digital clock on a website. Or, if you develop a movie streaming website, you can write code that responds to user actions such as clicking, mouse over, scrolling, and so on. In this way, you can allow a preview of the movie to play when the user hovers the mouse over the movie's poster. Or, you can think of a login page. When users click the login button, you can disable the button so that it cannot be clicked again. The web application would bring them to a new web page or would re-enable the button if a login error occurred. You can even add DOM objects to dynamically add new HTML content to a live web page. For instance, you can add an error message to a form if the user inserts invalid data. DOM objects can also be deleted, which will remove the corresponding HTML displayed in the browser. Think of a to-do list on a website. You can remove an item from the list when the user clicks on it. Another major use of JavaScript and the DOM is to animate the HTML elements. This can be quite complex depending on the animation, but there are many libraries available that aim to simplify this. For example, when a page first loads, you can fade in the page contents. Or, when a user receives an instant message, a notification can pop up in the web browser. Many JavaScript libraries and frameworks rely on the DOM. One of these libraries is the React library. By now, you know what the DOM is. how it is constructed, and the wonderful things web developers can do with it to create modern interactive websites. Next time you use your favorite social media site, think about how the DOM is working behind the scenes to change the color of that like button. As a web developer, you should try to ensure that everyone can access and enjoy the internet. Almost like an architect that needs to design a building with ramps and rails so that it is accessible by all. You need to build a website in a certain way to improve accessibility. When the Web Accessibility Initiative, or WAI, was launched in 1997, the creator of the World Wide Web, Sir Tim Berners-Lee, said, "The power of the web is in its universality. Access by everyone, regardless of disability, is an essential aspect. Web accessibility aims to allow people with disabilities to understand, navigate, and interact with websites. A common misunderstanding is that it refers to visual disabilities, but in fact, it includes all disabilities that affect interaction with websites, such as audio and visual disabilities, cognitive and neurological disabilities, and physical and speech disabilities." The W3C Web Accessibilities Initiative develops specifications and supporting resources for accessibility. These are considered international standards for web accessibility. In fact, web accessibility is becoming a requirement in many industries. In 2016, the European Union approved the Web Accessibility Directive, which requires websites and mobile applications of public section bodies to be accessible to those with disabilities. Let's explore some examples of how accessibility is provided to those with different disabilities. People living with disabilities often use assistive technologies to aid them in browsing the web. Screen reader software can read the content of websites and everything that is happening on the device. Screen readers are used not only by blind and vision impaired users, but also by those with reading or learning difficulties. Speech recognition software can turn spoken words into computer commands or dictate inputting text. This is useful for people who may not be able to use a mouse or keyboard due to physical or neurological disabilities. Subtitles and video scripts in videos provide assistance to those with audio and visual disabilities. There are many steps that you can take to improve accessibility. It is good practice to think of accessibility from the beginning of a project. It is a lot harder to rework the project to be accessible later on. If you use the correct HTML structure and appropriate elements as a foundation, it will greatly improve accessibility. In this course, you will learn to structure your HTML properly and follow best practices to support assistive technologies. For example, having text that is not contained within proper tags, like paragraph or heading tags, makes it harder for assistive technologies to interact with the content. Similarly, using multiple line breaks to break up text and add space also presents barriers to accessibility. These are just simple examples to improve web accessibility. However, in the future, you'll probably develop very complex user interfaces, and to make them accessible may not be as straightforward as just having correct HTML. Fortunately, one of the tasks of the WAI is to define the Accessible Rich Internet Application, or ARIA specification. The ARIA specification outlines different techniques to improve accessibility for complex web apps. Now you know about different assistive technologies and that you should use the correct HTML structure and appropriate elements to improve accessibility. I'd like you to think of a physical building and its structure, interior, exterior, and decorations. In a similar fashion, when it comes to websites and web apps, you can think of HTML as being the frame and structure. CSS, however, is the paint, wallpaper, fixtures, artwork, and overall style or look and feel. In other words, CSS tells the web browser how to display HTML elements on screen. When using CSS, there are 5 elements you need to understand. A declaration block starts with a left curly bracket and ends with the matching right curly bracket. In between these curly brackets are the style declarations. Let's cover these elements one by one. The first element of the CSS rule is the selector. This indicates which HTML element or elements you want to style. For example, you can create a rule that uses the H1 selector to change the color of all heading 1 tags in a web page to gray. In this case, H1 is the selector, color is property, and gray is the value of the property. You then create a declaration block using opening and closing curly brackets. The declaration block holds information about the properties and values that you are going to apply to the selector. Now let's focus on the structure of the declaration block. Each declaration is made up of two parts, a property and a value. For example, in this case, the properties that you want to change are the color and the background color of the header or selector. Once you have decided which properties you want to define, then you must assign each property a value. The color property gets a value of blue and the background color property gets a value of gray. This will result in all heading 1 tags displaying blue text on a gray background in the browser. By now, you'll have learned that CSS tells the web browser how to display HTML elements on screen. Now, let's work through an example to change a set of heading elements using different CSS rules. I will share a pro tip demonstrating how to install and use the VS Code extension Live Preview to speed up your workflow. Okay, so I'm back in Visual Studio Code here. Did you know that you can add additional functionality by using extensions? If you click on the Extensions tab, you can install the Live Preview extension by Microsoft. If you are running VS Code locally, you can install and use this extension. Once installed, right-click on your HTML file in the Explorer panel and select Live Preview, Show Preview. When you update an HTML file, you immediately notice the changes in Visual Studio Code. In this video, I will demonstrate how to create a CSS file and style some HTML elements. Before I start styling elements, let's create a simple HTML document named index.html. To demonstrate how CSS works, I will use an example created previously. Next, I create a file named style.css. For my web page to use the CSS file, I need to link it to the head element of the HTML file. To link to a style sheet, you use the link tag, which must be assigned two attributes, rel and href. The rel attribute is assigned to style sheet, and the href attribute is assigned to the name of the style sheet file. In this example, it's style.css. I am now ready to apply CSS to the index.html file using style rules that I will write in the style.css file. The selector I am creating applies the CSS rule to all H1 elements. This type of selector is called an HTML type selector. The properties in the declaration block allow me to change how the selected elements are displayed. For example, I'm setting the color property of all the H1 elements to display text in purple. I save the file using Ctrl and S. Notice that this change occurs immediately and there is no need to refresh the web page. So now, what if I want to only style a single H1 element? I can add an ID attribute to the H1 tag that I want to style, and in my CSS file, I create a rule for that ID. Let's do that now. First, I create an ID rule using the hash symbol and then the name header 1. Then I define the CSS properties of that rule to change the color value to green. I apply the rule and save the file using Ctrl and S. Notice that the text for the heading Chapter 1 on the web page turns green. You may be wondering, why does the first CSS rule not apply to the H1 element with the ID? This is because of something called CSS precedence and specificity. This is a complex statement, but basically, the browser will use the most precise selector for an HTML element. CSS has a set of hierarchy rules which dictate which rule will apply to an element. In this example, the ID rule takes precedence over the HTML type selector rule. You can learn more about CSS selector rules and precedence from the additional reading at the end of this lesson. Congratulations! You have now learned about the selection and styling in CSS. Let's quickly recap. After choosing a selector for your styles, you create a declaration block using opening and closing curly brackets. Inside of the code block, you write a declaration which consists of a property value, pair ending in a semicolon. And all these parts together, the selector, code block, and declaration make up a CSS rule. I encourage you to add some CSS rules to your HTML documents to practice selecting and styling. Just like a busy day at a restaurant, a website can easily look squashed and busy. With waiters having to maneuver their way around and customers' chairs up against each other, it can get messy. Good restaurants usually have carefully planned layouts to make customers feel comfortable and allow waiters to move around with ease. Sometimes, creative web development requires thinking inside the box. In this video, I will demonstrate how to use the box model in CSS to create an appealing layout and allow users' eyes to easily flow between content. When an HTML document and CSS style sheet are downloaded, the web browser needs to know how to display the elements on screen. To do this, it allocates a rectangle or box to each element. CSS rules are applied to the boxes of the elements. This is known as the box model. Every box consists of 4 parts: the content, the padding, the border, and finally, the margin. The content is the actual content of the element, like the text or the image. Its size is known as the content width and content height. Browsers are clever, and by default, they will calculate the width and height based on the content itself. Fortunately, developers can control the size to manipulate the layout. You can do this by applying CSS rules to the content, such as width, maximum width, height, minimum height, and maximum height. Let's move on to the padding. The padding extends the content size. Its size is known as the padding box width and the padding box height. The thickness of the padding is determined by the padding top, padding bottom, padding left, and padding right. The padding box width can be calculated as content width plus padding left side plus padding right side. And you can calculate the padding box height by adding the content height, the padding top side, and padding bottom side together. Next, let me show you how you set the border. The border goes around the padding and content. Its size is known as the border box width and border box height. You can set different types of borders, such as solid border or a dashed border. To understand how this plays out practically, I will demonstrate the HTML, the CSS style, and the physical border. To set the border, you can write border width thin, border width medium, and border width thick. Now, let me share with you a pro developer tip to help you calculate the size of your HTML elements when working with the box model. An HTML element is equal to the size of the border box. To get the border box width, you add the padding box width plus the border left side plus the border right side, and you can calculate the border box height by adding the padding box height and the border top side as well as the border bottom side. Lastly, let me show you how to set the margin. Following on from what you have just learned, do you have an idea of what the CSS rule might be? The margin extends the border area to separate the element from its neighbouring elements. Its size is known as the margin box width and margin box height. To specify the margin size, you write margin top followed by the value. The margin bottom, margin left, and margin right follow the exact same notation. You can also set the padding, border, and margin with shorthand properties, but more on this later. Lastly, let's calculate the size of the margin box. Can you guess how? The margin box width can be calculated by adding the border box width, the margin left side, and the margin right side together. To get the margin box height, add the border box height, margin top side, and margin bottom side together. To easily remember this, think of the content as yourself. The padding is like the thickness of your clothes. The border is like the silhouette or outline, and the margin is the personal space between you and another person. In this video, I've opened the box model for you. Inside it is the content, and around it flows the padding. The border fits around the padding, and lastly, the margin is the empty space keeping elements apart. You will work with the box model in every website you develop, so I encourage you to start practicing with it in your designs. By now, you've learned how CSS styles individual HTML elements. But how does the web browser know where to place the elements on the screen? The web browser's normal way of calculating the position of HTML elements on the screen is called document flow. By default, nearly all HTML elements are organized into one of 2 categories, namely in block and inline elements. A block level element will occupy the full horizontal width of its parent element and the vertical height of its content. Each block level element will have a new line before and after. Therefore, multiple block level elements will stack on top of each other like a stack of boxes. Inline elements only occupy the width and height of their content. They don't appear on a new line, hence the name inline. Therefore, multiple inline elements can form a row of elements. When coding in HTML, you need to be able to recognize and use block elements. Some examples of block-level elements include the tags div, form, and heading. You also need to be familiar with common inline elements. These include the tags anchor, image, input, label, bold, italics, emphasis, and span. Let me demonstrate the difference between block and inline now by using an example of an HTML file containing div and span elements. Okay, so I've opened Visual Studio Code here. I will now demonstrate an example where you will learn about document flow. First, I want you to notice that I have a div element containing 3 sentences of lorem ipsum. A div or divider element is used to divide content into sections. If you don't speak Latin, don't worry. Lorem ipsum is placeholder text that has been used since the 1500s. Each sentence contains a span element that you may recall are inline elements. Notice that all text is displayed in an unbroken flow of content in the browser. In the code, I have div and span elements. I am now going to change the middle sentence from a span to a div tag. Because the div tag is a block-level element, notice that the sentence has been moved to a new line and the span element after it is also on a new line. It's possible to change elements from block level to inline and vice versa. This can be done using the display CSS property. Let me add a CSS file called style.css. In my HTML file, let me give the middle sentence div element an ID. I now add a rule in the CSS file to change the element to an inline element. To create the CSS rule, I type #middle and open the curly brackets. On the next line, I type display : space inline semicolon, and on the next line, I close the curly brackets. Notice that the div has now changed to an inline element. If I want to change it back, I can just remove the property. I have deleted the rule in the code to change the element to an inline element. Another way to achieve this outcome is to set the display property to block. I have now changed the value for display to block. In another video, I'll demonstrate to you that there are other values you can set for the display property to change the layout behavior of an element. Congratulations! You have now learned about block and inline elements in HTML. It's important for developers to be comfortable working with each and to know the differences. It's vital to keep in mind that block elements start on a new line and span the entire page, and inline elements work within the flow of the surrounding content, rather than breaking onto their own line. You've reached the end of this introductory module on HTML5 and CSS. It's now time to review what you've learned in these lessons. This module started with a lesson on the basics of HTML, or hypertext markup language. You began this lesson by exploring the answer to the question, what is HTML? You learned to describe the purpose of HTML in a web browser, demonstrate the use of HTML tags, including how to ensure that you use the correct syntax, identify how HTML elements are utilized in a web document. You also explored HTML documents, and you should now be able to outline the structure of an HTML page, including the root, head, body, and other elements, demonstrate how to build basic HTML documents by combining common key elements and tags in order to create a structure, and explain how to create a link between HTML documents with the use of an href or hypertext reference attribute to redirect users between the documents. You should also be able to add images to a web page with HTML code, utilize HTML to manipulate data in tables, and build HTML forms with a wide range of input types. You then moved on to study the document object model, or DOM, a tree structure or model of objects in an HTML page. During your investigation of the DOM, you learned how to explain what the DOM is and the purpose that it serves with an HTML document, demonstrate how the DOM is created from an HTML page by exploring the elements that generate it and visualizing it in diagram form, and provide a high-level description of common instances in which web developers interact with the DOM through JavaScript. These include updating content, setting up events, and animating HTML elements. You also explored the concept of web accessibility by exploring how people with disabilities can understand, navigate, and interact with websites. Following your exploration of this topic, you should now be able to demonstrate high-level knowledge of assistive technologies used to browse the web, like screen reading and speech recognition software. Make use of basic techniques to improve the accessibility of your web projects, such as correct HTML structure. Following this introduction to HTML5, you then covered a lesson on the basics of CSS or cascading style sheets. The lesson began with an overview of selecting and styling, in which you learned to write CSS rules in order to style elements within an HTML document, demonstrate an understanding of the box model and its key features, and explain the concept of document flow. You then demonstrated your skills in these topics by creating a biographical web page, the first of many web pages you'll create in this specialization. You should now be familiar with the basics of HTML5 and CSS. Well done. You're making good progress on your learning journey. Hello and welcome. Imagine you want to cook a dish you never tried before. You can try different ingredients, different cooking times, or you can just use a recipe you found on the internet. In a similar way, as a developer, you can try to build your website from scratch, or you can use code that other developers created. In this video, I'll illustrate how to include CSS and JavaScript libraries in your HTML file. I'm also going to explain what dependencies are, the purpose of a package manager and JavaScript bundlers. Let's get started. By now, you know you write code in your application and that this code interacts with APIs provided by libraries and frameworks. Since you'll be deploying your application to a web server in the end, you must include these libraries and frameworks with it. If you do not include them, your application won't be able to call the API functions it needs to execute when you run it. That is why the libraries and frameworks are often referred to as dependencies. Your application depends on them. On the front end, you do this by referencing the JavaScript or CSS files in your HTML file. One popular library you can use to develop user interfaces is the Bootstrap library. You will learn more about Bootstrap in this course, but for now, let me demonstrate how a library such as Bootstrap can be included on a web page. Start by opening your HTML file. Next, add the CSS library for Bootstrap in the head element using a link tag. The link tag includes an href attribute to link the CSS library I am including. I also included a rel attribute to specify that the link is for a style sheet. Bootstrap also provides a JavaScript library that enables enhanced functionality such as drop-downs and tooltips. You'll likely need those features during development. So let me demonstrate how to add the JavaScript library to your web page. Open your previous file that already has the Bootstrap CSS. Next, add the JavaScript library for Bootstrap in the body element, using a script element. I then add an src attribute to the script element to specify the link to the library. Let me add a Bootstrap button to the page to demonstrate how easy it is. In the body, I add the button element. Then I add an attribute called type and the CSS class btn. I also add the modifier btn-primary and a description. Click this button. This will add a button using Bootstrap's primary color, blue, on the web page. This is what the rendered version of the code will look like. You can now start using the additional Bootstrap functionality. This is quite a simple example. In day-to-day development, however, it can end up being a lot more complicated. For example, what happens if your dependency also depends on other libraries and frameworks? This is known as a dependency tree. A project could have hundreds of dependencies in its tree. It will take a very long time to download, set up, and configure all of them. And how do you make sure you're using the same versions the rest of your team is using? This is where package managers come in. A package manager is a tool that automatically downloads and installs dependencies. We also refer to dependencies as packages. A package manager also provides the capability to publish your own packages. But let's not worry about that right now. For each dependency, you can specify a version of that dependency, and the package manager will download it for you. If there is a dependency tree, the package manager takes care of that for you. It will automatically download all of the dependency tree so that you can use APIs without dependency issues. The most common package manager for front-end development is the Node Package Manager, or NPM for short. You will have an opportunity to explore using NPM in this program. Now that all your dependencies are downloaded, you need to include them in your HTML file. But adding all of them into an HTML file would take forever. This is where you will use a bundling tool. The purpose of a bundler is to automatically combine them into a single file. If your bundle is significantly large, many bundlers can split your dependencies into multiple bundles. There are many bundlers available, such as Gulp and Webpack. We'll be exploring bundling in more depth later on. You now know how to include CSS and JavaScript libraries in your HTML file. You also know what a dependency is, what the purpose of a package manager is, and what JavaScript bundlers are. Have you ever wondered how the size of a website can so easily adjust between different devices like laptops and mobile phones? Well, the answer is responsive design. Responsive design means that a web page can automatically stretch or shrink depending on the screen it's displayed on. In the world of web development, you use responsive design every day. Let me share how it works. In this video, you will be able to explain how responsive design is used to provide the best user experience based on the device that the website is viewed on, describe CSS media queries and screen resolutions, classify fluid images, and differentiate between fixed and fluid grids. Phone, tablet, and computer screens, including the one you're probably using now, are made up of thousands of tiny lights called pixels. The resolution of your screen refers to the number of pixels it contains, most often expressed as the number of horizontal pixels multiplied by the number of vertical pixels. For example, a common computer screen resolution is 1920 pixels in width and 1080 pixels in height. Thanks to responsive design, websites can be correctly displayed on any of your devices. However, today we have many different screens with different resolutions, which is why responsive design is so important. And it is complicated by new high-resolution screens like the one found on your mobile phone. These screens group multiple physical pixels into one logical pixel to display smoother images and text. These are often used in your favorite smartphones to give more high-definition visuals, like making text, images, and rounded edges appear smoother and making the individual pixels less visible. Given all the possibilities and complicating factors, it would be challenging to develop websites that appear correctly on all kinds of devices if it wasn't for responsive design. Responsive design is a set of 3 practices that allows a website to automatically change its visuals. In other words, to respond based on the device it is displayed on. It is the combination of 3 techniques: flexible grids, fluid images, and media queries. Firstly, flexible grids are made up of columns, gutters, and margins. The space between the columns is called the gutter, and the spaces between the content and the left and right edges of the screen are called margins. Instead of defining website element sizes based on pixels, flexible grids are defined in percentage values, allowing them to adjust depending on screen size. Next, you have fluid images. By setting the CSS max width property of images to 100%, the images will scale down smaller if their containing column becomes narrower than the image's size, but never grow larger. This enables an image to scale down to fit in a flexibly sized column, rather than overflow it, but not grow larger and become pixelated if the column becomes wider than the image. Finally, there are media queries that are part of CSS. They allow developers to query the display size, orientation, and aspect ratio to conditionally apply CSS rules. For example, if you wanted your website background to appear blue on a screen size less than or equal to 700 pixels, like on a mobile phone, you could use a media rule to set the background depending on the size of the screen. Remember that I said responsive design is the combination of flexible grids, fluid images, and media queries. When these elements are used together, you build a website that will automatically adjust its layout based on the device, thus delivering a responsive grid. In responsive design, the pixel value specified is often referred to as the breakpoint. A breakpoint is the point at which a website's content and layout will adapt to provide the best possible user experience. A breakpoint can function in different ways across 3 different grids: a fixed grid, fluid or full width grids, and lastly hybrid grids. Let's explore each of these now. Firstly, a fixed grid has fixed width columns and flexible margins. The fixed grid has a fixed content width that doesn't change in a specific breakpoint range, while the flexible margins occupy the remaining space on screen. Then, We have fluid or full width grids with fluid width columns and fixed gutters and side margins. The fluid grid has a flexible content width that goes edge to edge as per the screen size. In a fluid grid, columns either grow or shrink to adapt to the available space. And finally, there are hybrid grids that have both fluid width and fixed width components. Many responsive design frameworks provide multiple CSS rules based on different device sizes to provide the best visual experience. Now you know the importance of responsive design. In the next few videos, you are going to learn more about Bootstrap, the world's most popular framework for building responsive mobile-first sites.
Part of designing a website is thinking about how different UI elements and menus are positioned on the page and in relation to each other. Bootstrap is a collection of pre-written code chunks in CSS and JavaScript that allows you to create websites more quickly than if you had to create every bit of code from scratch. Building websites from scratch every time would be quite time-consuming. This is where Bootstrap comes in. In this video, you will learn how to create a simple Bootstrap webpage. To do that, I am using the file with the Bootstrap libraries I have created. So let's begin by setting up the layout. The first element I need to add when setting up a Bootstrap website is the container element. I need it before I can use the Bootstrap grid system. So I add an HTML div element and apply the container CSS class provided by Bootstrap. Next, I add a row for the content. Similar to what I had in the container element, a row is an HTML div element which uses the row CSS class provided by Bootstrap. I add the row CSS class below the container CSS class. Under this row, I want to add two columns, one for the menu items and one for the prices. So I add two div elements with the col CSS class, one for each column. Col is short for column. Now I want to name the columns. I do this by adding heading tags in each div. Within the first column div element, I add a heading 1 tag or H1 tag, and I type the name of column 1, our menu. In the second column div element, I type prices in an H2 tag. Under the Our menu column, I will add the name of each dish, the ingredients used, and an image. First, I add a heading 2 tag below the Our menu H1 tag, and inside it, I add the name of the dish, falafel. Under the falafel H2 tag, I add a paragraph or P tag. Inside this tag, I list the ingredients: chickpea, herbs, and spices. Now to add an image of our falafel, I add the img or image tag, and inside it I add the src or source attribute as it is known. In the source attribute, I enter the name of the image file I want to link to. I type falafel.jpg as a source for the image. I now add a CSS class called img-fluid or img-fluid as most developers call it. Instead of having to manually set the image size, the img-fluid class will ensure my image scales to its parent column's width. Next, let's add another dish. I add another heading 2 or H2 tag, and inside it, I add the name of the dish, pasta salad. Under pasta salad H2 tag, I add a paragraph or P tag and list the ingredients: lettuce, vegetables, and mozzarella. Now I add another image tag, and inside it I add the source attribute. In the source attribute, I enter the name of the image file I want to link to. I type salad.jpg as a source for this image. I also add the same CSS img-fluid. Now I save the file by pressing the keys Ctrl and S, or if you're on a Mac, Command and S. Next, I preview the web page in Live Preview. The dishes are now displayed in columns and the images are sized correctly. Now let's add the price table. So under the price column, I add an HTML table tag and apply the Bootstrap CSS class for tables. Inside the HTML table tag, I add two table row tags or TR tags. This will create a row for each of the dishes. Then I need to add table data tags or TD tags. Table data tags define the contents of table cells, so I will need to add two of those inside each row, one for the dish name and one for its price. In the first row, I add falafel to the first TD tag, and in the second TD tag, I add the price. Let's say $12. I do the same with the second row. I type pasta salad inside the first TD tag and the price of $10 in the second TD tag. I save the file again by pressing Ctrl and S, or if you're on a Mac, Command and S. Next, I preview the web page in live preview. The table structure now displays using the Bootstrap's table style. You have now learned how to make a simple web page using Bootstrap.
As a developer, you are tasked to design a website for the Little Lemon restaurant. One of the main requirements is that the website easily adapts to different devices, platforms, and screen sizes. Does this mean that you'll have to redesign the website for each device? No, relax. You do not have to redesign your website for each device. In this video, I'll introduce you to Bootstrap CSS class infixes and modifiers, and you will learn how you can use them to save you time. Let's get started. Bootstrap has quite a large CSS library, built by Bootstrap's developers using thousands of use cases. How it achieves this is through CSS classes and their variations through infixes and modifiers. It is important that you, as a developer, understand infixes and modifiers, and you will explore each of these terms. You will use class infixes for responsive breakpoints in the Bootstrap grid system. Let's go ahead and cover how infixes are used. You already know that breakpoints are the triggers in Bootstrap for how your layout changes across device or viewpoint sizes. Here are the responsive breakpoints available in Bootstrap and how we use them. Note that each has a specific name. Extra small is for screens less than 576 pixels wide. Small is for screens greater than or equal to 576 pixels wide. In Bootstrap CSS rules, this is abbreviated as SM. Medium is for screens greater than or equal to 768 pixels wide. In Bootstrap CSS rules, this is abbreviated as MD. Large is for screens greater than or equal to 992 pixels wide. In Bootstrap CSS rules, this is abbreviated as LG. Extra large is for screens greater than or equal to 1200 pixels wide. In Bootstrap CSS rules, this is abbreviated as XL. Extra large is for screens greater than or equal to 1400 pixels wide. In Bootstrap CSS rules, this is abbreviated as XXL. Did you notice that there is no class infix or dimension for extra small on the list? This is because extra small is the default breakpoint in Bootstrap CSS rules, as Bootstrap is mobile first. We use the abbreviations for these breakpoints as infixes in the CSS rules for the grid system. This basically means you have to insert the abbreviation into the CSS class name. I will show you how to use this shortly. Bootstrap components provide a pre-built set of reusable UI styles and elements for your web applications. Let's now learn how to use modifiers through an example that uses an alert element. I can have an HTML file where I set an alert primary CSS class that is applied to the element. Alert primary displays the alert using Bootstrap's primary color, which is blue. The dash primary part of the class is the modifier. If you want to change this to red, for example, for an error message, you will use the danger modifier. Here is a list of modifiers available in Bootstrap. Primary, secondary, success, info, warning, danger, light, dark. Alerts are often used to show information that needs immediate attention from users, such as warnings, errors, or confirmation messages. Bootstrap provides an easy way to create predefined alert messages, and it also has different types of alerts. The difference between the alerts is just the color used to display the predefined alert message. For example, the primary alert displays the alert using Bootstrap's primary color, which is blue. On the other hand, the danger alert displays the alert in red. Now, let's turn our attention to how this works in code. In this HTML file, I have a 6-column CSS class applied to a div element. In this example, I want to change this rule for large screens. To do this, I infix LG into the col CSS class by adding col-lg-6. Bootstrap components provide a pre-built set of reusable UI styles and elements for your web applications. For example, I can add an alert component. I do this by adding an alert CSS class, followed by the contextual class alert-primary. Now I have to identify the function of the alert. To do this, I add a role CSS class directly after the contextual class alert-primary and type alert. On the next line, I type the name that must be displayed on the alert, a message. Alerts are useful for displaying information, warnings, or error messages to users. The contextual class alert-primary will display the alert using Bootstrap's primary color, which is blue. The primary part of the class is the modifier. If I want to change the color to red, for example, for an error message, I will use the danger modifier. To change the color to red, I simply replace the modifier primary with danger. Now you have learned about CSS class infixes and modifiers and how you can use them to save you time. As you have previously learned, building a website using responsive design requires a responsive grid and responsive breakpoints. Bootstrap provides both of these as part of its library. The Bootstrap grid system helps us to create web page layouts through a series of rows and columns that house our content. For the grid, Bootstrap uses a 12-column grid system that can be fluid or fixed. The Bootstrap's grid system always has a container, rows, and columns. The container is the root element of your grid. Bootstrap's grid system always starts with the container. The container contains pads and aligns your content. Its width is determined based on the current responsive breakpoint. You can add rows, and inside each row you can add columns. Let me demonstrate how we put this all together by using Little Lemon's website as an example. Alright, I have opened my joesburgerindex.html file. In this web page, I have added 2 columns to my row. Bootstrap is smart and will set the 2 columns to span 6 column spaces. If I want to control how many spaces a column uses, I can suffix a number. Let's shrink the price column to 4 spaces and expand the menu column to 8 spaces. To do this, I add the suffix -4 to the col CSS class above the prices heading. I also add the suffix -8 to the col CSS class above our menu heading. But here's the amazing part of Bootstrap. I can configure my content to use different layouts based on the device using the breakpoint-specific CSS rules. Let's have the content stack on top of each other on mobile devices and have them display side by side on desktop devices. Since columns will wrap to new rows, if we exceed the 12-column space, we can use this to stack content. For mobile devices, I'll set the columns to use 12 spaces, each by adding -12 as a suffix to the col rule for both columns. Then for desktop, I'll set them to 6 columns each by using a col-lg rule and adding the column sizes -6 as a suffix. I will save the file by pressing Ctrl and S or Command S on a Mac and open it on my web browser. Notice that now the columns are side by side. Next, I open my web developer tools by pressing the F12 key. In the top left corner, there is a mobile phone tablet button. Clicking on this button enables the device mode. This allows me to simulate different devices. I select to view my website on a mobile phone device. Amazing! My content has stacked vertically on mobile. Bootstrap has ensured our website will work on a mobile phone thanks to its CSS rules and grid system. This will save a lot of development time by not needing to develop different content layouts per device. Bootstrap's grid system is very powerful and suitable for most development needs.
Bootstrap includes a pre-made set of UI elements and styles to help you build your website. They range from alert messages to navigation menus. These are called Bootstrap components. In this video, you will learn how to use Bootstrap components. Little Lemon have added a new fried calamari dish to their menu, and they want to add it to their website. They also want to update their website to use Bootstrap components. First, let's add the new dish. To do this, in the menu column, I add a new H2 tag, and inside it, I add the name of the dish, fried calamari. Then I add a paragraph tag. Inside this tag, I list the ingredients: squid, buttermilk. Now I want to add an image of the fried calamari. So I use an image tag with its source attribute and the image file name calamari.jpg. And I add image-fluid class to ensure the image scales to its parent column's width. Bootstrap comes with a badge component that I can use to highlight that the dish is new. Let's add that now. Next to fried calamari, inside the H2 element, I add a span element and assign it a CSS class of badge. Now I can set the background color of my badge by adding another class bg-primary. The contextual class bg-primary will display the badge using Bootstrap's primary color, which is blue. Inside the span, I add the text new. Next, I'm going to improve my visuals by using the card component for each dish. With card elements, I can style and accommodate different types of content like title, subtitle, body copy, and images. For the cards, let's have them stack on mobile devices and tile side by side on desktop. To do this, I add a row below the R menu H1 tag. I then add a div element for each dish of the 3 dishes. For each div, I apply the col-12 class for mobile devices and col-LG-6 class for desktop devices. Inside each div element, I add another div element that uses the card CSS class by adding one and copying and pasting it inside the other divs. I then move the code with the image tag of each dish to the card class. Instead of using img-fluid, I change each image to card-img-top. This will improve its visual style within the card. I then add another div for each dish and give it the card-body class. This will contain the text content of the card. I then move the header and paragraph of each dish into these card body elements. Again, to improve the visual style, I add a card-title CSS class to the header of each dish. In the paragraph element, I add a card-text CSS class for each description. This will contain the dish ingredients. Our menu has a much better layout now. Finally, let's update the prices. Under the price column, I add a table row or TR tag for the new dish. Then I add 2 TD tags. TD stands for table data, but from now on I will just refer to it as TD. In the first row, I type fried calamari in the first TD tag, and in the second TD tag, I type the price $12. Then I add an alert to inform our customers about the new dish so they can try it out. To do this, I add a div element with the alert CSS class. I add the alert-info CSS class to change the alert to blue. Now I identify the function of the alert by adding a role attribute directly after the contextual class alert info and type alert. On the next line, I type the text that must be displayed on the alert. Try our new fried calamari. The website has a much better layout now. Hopefully Little Lemon will have a lot more orders now. There are many components available in Bootstrap. Maybe there are some more you can use to improve your website.
I'm sure you've noticed that when you shop online, websites will often provide you with personalised recommendations, but when your friends log into those same websites, the recommendations will differ. But did you ever wonder how websites adapt to different user profiles? In this video, you will learn the difference between static and dynamic content. You will also be able to differentiate between the role of a web server and an application server. By now, you know that when you open a website, a web server sends the website's content to your browser. The content can be static or dynamic. Static content is files that the server transfers just as they are stored on the web server, such as videos or images. Dynamic content, on the other hand, is generated when the HTTP request is made. For example, the content may be generated based on input from a user, or when you visit a news website, it would be based on the current date. What actually happens is that the web server communicates with another kind of server, called an application server or a backend. The application server generates the dynamic content that the web server sends back to the user's browser. Now you know the difference, let's look at examples of how websites update static and dynamic content. Say, for instance, you want to watch a video on a website. You click on the play button and a request is sent to the web server. The web server responds by sending the file to your browser. Now, how does this compare to dynamic content? Because dynamic content is generated while you use a website, it typically takes longer to generate than it takes to send back static content. For example, when you log into this course, the web server communicates with an application server to check that you are in fact enrolled. The application server confirms your enrollment and specifies what content should show for your profile specifically. Application servers perform more complex processing than web servers. For instance, they have to run application logic, communicate with a database, and check permissions. To improve performance, different application servers have specific purposes. There are application servers for every type of content out there, from music streaming to creating your own blog. You can even create your own application servers, such as building a backend for a web application. But hang on, if dynamic content is slower to generate, isn't that a problem for big websites? Yes, it is. Application servers typically have a limited capacity on how many requests they can process per second. But fortunately, this is where the web server can help out. Web servers use a process called caching instead of generating content dynamically for every request. Caching means the web server keeps a copy of dynamic content. If the content is requested again, the web server can immediately send this cached version instead of passing the request again to the application server. On the first request for dynamic content, the web server checks if the content exists in the cache. If it does not exist, the content is requested from the application server and stored in the cache. The web server then sends back the dynamic content to the browser. On subsequent requests, the web server immediately sends back the content stored in the cache. This reduces the amount of dynamic content that the application server has to generate. Then, after a period of time or with the next user interaction, the web server updates the cache with the latest content. Now you know the difference between static and dynamic content, as well as the difference between web and application servers. With this new information, try to identify whether the content on the websites you visit is static or dynamic. Let's say that you're thinking of building a web app. You probably want a user-friendly, mobile-friendly experience. Then you should consider using single-page applications or SPAs to build a unique, speedy, and engaging experience for your users. You're probably using many SPAs every day. Think of your favorite social network or messaging app, or the map application you use to find local businesses. The great user experience you get is driven by single-page applications. So, what exactly is an SPA? How does it work? How is it different from a traditional website? Let's first explore how a traditional website works. Before the advent of modern JavaScript frameworks, most websites were implemented as multi-page applications. But this makes traditional applications resource-intensive to web servers, because sending entire web pages for every request consumes excessive bandwidth and uses CPU time to generate dynamic pages. If your website is complex, the site browsing experience may appear slow to users. It will be even slower if they have a poor or limited internet connection. To solve this problem, many web developers build their web applications as SPAs. It's called single page, but that doesn't mean your website has only one page of content. What it means is that there is only one HTML page that gets sent from the server to the browser. But that page will update its content as your users interact with your website. A SPA allows the user to interact with the website without the application needing to download entire new web pages. Instead, it rewrites the current web page as the user interacts with it. The result is a browsing experience that feels faster and more responsive to user input. When the user navigates to the web application in the browser, the web server returns the necessary resources to run the application. A SPA has two approaches to serving code and resources. The first is called bundling, and the second approach is known as lazy loading or code splitting. With bundling, when the browser requests the application, the server returns and loads all necessary HTML, CSS, and JavaScript immediately. With lazy loading, the browser requests the application, and the server returns only the minimum HTML, CSS, and JavaScript needed to load the application. Additional resources are downloaded as required, for example, when a user navigates a specific section of the application. Both approaches are valid. The choice depends on the size, complexity, and bandwidth requirements of the application. For instance, with the bundling approach, if your application is complex and has a lot of resources, your bundles will grow quite large and take a long time to download. You could end up with a site that is slower than a traditional web application. Let's explore an example. Imagine you have a site dedicated to reviewing movies. People never know what to watch next, so you decide to install a feature that randomly suggests the movie for a user. You create a web page that has a What to Watch Next button. You want to display a random movie name when the button is clicked. In a traditional website, when the button is clicked, the browser will send a post request to the web server. The web server returns a new web page containing the button and movie name. The web browser then renders the new page. In an SPA, when the button is clicked, the browser will send a post request to the web server. The web server will return a JSON object. The application reads the object and updates by displaying the text of the movie name. That's more efficient because the rest of the page remains as it was, and its content does not need to be sent by the server and rendered by the browser. But what if you need to update the majority of the page to display a different form of content? Well, let's explore that scenario. Suppose you are building a web application that has two pages. One page shows the latest news, and the other page shows the current user's profile page. A navigation bar at the top of the site contains a link to each page. In a traditional website, when the user clicks the profile link, the web browser sends the request to the web server. The web server generates the entire HTML page and sends it back to the web browser. The web browser then renders a new web page. In a single-page application, different pages are broken into templates, also known as views. Each view will have HTML code that can be updated by the application. For instance, the profile page would have a username, a first name, and a last name. The web browser sends the request to the web server, and the web server sends back a file called a JavaScript Object Notation, or JSON object. This contains only the data to be displayed, such as a user's first name and last name, and the SPA will update the HTML. This is much smaller than sending an entire web page. The web browser then updates the web page by inserting the template with items replaced by the values in the JSON object. For your next website, consider whether its complexity suits a traditional multi-page application or would perform better as an SPA. remember that a single-page application has two methods of delivering resources: delivering all resources immediately or delivering resources dynamically as required. If all resources are delivered when the application is loaded, the single-page application must include the views for every page on initial load. If resources are loaded dynamically, the single-page application requests the views as required and stores views in the browser for subsequent requests. Now you can compare some popular SPA websites to traditional ones and judge the performance difference for yourself. I'm sure you've created something from scratch before. I bet you realised how challenging it can be as opposed to using pre-made components. Think about the effort that goes into building a brand new house versus the convenience of constructing a modular building with pre-made components that you just need to put together. React is focused on working with components, which makes it simple to build functional user interfaces on web and mobile. And since React is one of the most popular JavaScript libraries, it's important that you can explain what its purpose is and describe how its components work together. Available since 2013, React is an open source library with a community of core contributors and companies that maintain it. Developers use React to develop single-page applications, and you can also develop mobile applications with React Native. When you develop an app, you can choose to use React to develop the user interface, but building an application requires more than that. You must also consider the navigation and how the app will request data from a web server. Therefore, React is used in conjunction with other JavaScript libraries during development. But what makes React so useful is that it allows developers to write less code to create functionality. This in turn makes it easier to maintain code in the long term and simplifies testing. Because it is so central to front-end development, there are many tools that you can use with React. These tools can help you understand how React is running your code and how you can improve performance. Now that you have a better idea of what React is, let me tell you more about React's components. The key concept behind React is that it allows you to define components that you can combine to build a web application. A component is basically a small piece of user interface, such as a music player or photo gallery. This component model allows you to do several things, such as developing and testing parts of their application in isolation, and it also allows you to reuse components across multiple sections of the application as well. Let's explore an example. Most web applications have user profiles with pictures. Normally, several parts of the application use a version of this profile picture, such as in the navigation bar beside the user's name. It could also show in a user search result along with several other user pictures. And the user picture might also display in instant message notifications. Instead of programming the logic for every instance of a user profile picture, React allows you to create a user icon component that displays a version of a profile picture every time it is used. You can then reuse this component throughout the application. Can you imagine how it will improve your efficiency? There are, in fact, many open source libraries that provide pre-made components for React projects. For example, if you want to add a video player to your website, there's a React component library for that. Or maybe you want to embed a map. There's a React component library for that too. As the React community grows bigger, it continues to add new features and improvements continuously. Annual React conferences encourage community sharing and introduce upcoming developments in the library. I hope that in the near future, you might be joining the React community as an active member. And as a future React community member, you now know the React library's purpose and how its components work together to make life easier for front-end developers. After all, why build something from scratch if the components are already there to use? By now you've learned that you can build components in React to develop user interfaces. But how do React components turn into the elements on the web page that you see? Remember, when your web browser receives an HTML page, it constructs a document object model, or a DOM, to represent it. But updating the DOM is considered expensive because it is very time-intensive for the web browser to do so. Every time the browser DOM is updated, it causes the browser to recompute the page. Yet many big and popular websites still load in no time today. How can it be? In this video, I will explain how React solves the problem by computing its own virtual DOM. Let's start with how React components relate to the website displayed in your browser. A React component has a one-to-one relationship to an HTML element that is displayed on the web page. But how does React keep track of which HTML elements need to be updated? This is where React's virtual DOM comes into play. When React builds out its tree of components, it builds out its own DOM in memory called the virtual DOM. The virtual DOM is a representation of the browser DOM that is kept in memory. React uses this virtual DOM to update the browser DOM only when it needs to. This ensures that your application is fast and responsive to user input. Let me explain how it works. React checks to see if the HTML components in the virtual DOM matches the browser DOM. If a change is required, the browser DOM is updated. If nothing has changed, then no update is performed. This process is called reconciliation. Let's break down what happens when you update a component in React. Firstly, the virtual DOM is updated. Then React compares the virtual DOM to the previous version of the virtual DOM and determines which elements have changed. The changed elements and only those elements are updated in the browser DOM. Changes on the browser DOM cause the displayed web page to change. In this video, you've learned that React constructs and updates a virtual DOM so that the browser will only update certain HTML elements instead of recreating the entire page. Planning an application as a series of components can be tricky at first, but after doing it a few times, it'll become easier. You've already learned about the core internet technologies, and now you know that JavaScript libraries in React allow you to develop user interfaces much faster. Isn't it cool that you can develop user interfaces so quickly? In this video, you will learn how the component hierarchy works in React. Every React application contains at least one component, the root component or app component. Components are added to the app component to build out a tree structure of components that make up the application. Let's explore an example of how an application might be structured as components. Suppose your application is a shopping list of items that need to be picked up from the grocery store. At the root, we have the app component. The app component has two child components, new item bar and shopping list. The new item bar component allows us to add new items to the list. The shopping list component contains a shopping item child component for each item in the shopping list. Even though the item itself might be different, such as chicken or noodles, it is displayed in the same manner as other items. Therefore, you can reuse the shopping item component to display multiple items. When a user ticks off the items, the list will update and remove the corresponding shopping item child component from the shopping list component. Now that you understand the component hierarchy, let's explore how a website can be broken down into components. As an example, I will talk you through a typical blog website. Normally, there is a heading, a menu, and a search bar. You also usually have a featured blog post that displays larger than previous blog posts below it. Now, let's unpack the component hierarchy. At the root of the component hierarchy, you have the app component. This is the entire web page. The app component has two child components, the navbar component for the navigation bar and the page component. The navbar component contains the title of the blog, navigation links for the website, along with the search component. In the page component, we have three components, the main feature component and two instances of a small feature component. The main feature component displays a blog summary about a specific blog post. In the small feature component, there is a blog summary and a thumbnail component to display an image associated with the blog post. Notice that the small feature component is used twice. It is the same piece of code, but for the second small feature, the code uses different properties. And that is exactly the benefit of building a website with React components. You can reuse code for multiple sections. Using a series of components to build an application can be tricky at first, but after you do it a few times, you will appreciate how handy it is. Good luck with planning your component hierarchies in React. You've reached the end of this module on UI frameworks. It's now time to review what you've learned during these lessons. Over the course of this module, you've explored the concepts of UI frameworks and libraries and covered an introduction to React. Let's recap the key points you learned and the skills you gained. You began the module with an introduction to UI frameworks. Following the completion of this first lesson, you should now be able to utilize CSS and JavaScript libraries, demonstrate a high-level understanding of dependencies, package managers, and JavaScript bundlers, and explain the key techniques and concepts of responsive web design, such as screen resolutions and fixed and fluid grids. You should also be able to develop a simple Bootstrap website with the use of HTML and CSS, Utilize Bootstrap CSS library, including deploying class infixes for responsive breakpoints and class modifiers to change your CSS code, and demonstrate an understanding of Bootstrap's grid system by building a web page using the Bootstrap grid. Following your exploration of UI frameworks and libraries, you then covered an introduction to React and the JavaScript library for building user interfaces. Now that you've completed an introduction to React, you should be able to differentiate between static and dynamic web page content, list examples of how each type works in the context of web servers, explain what a single page application is, how it works, and how it differs from traditional web applications. You should also be able to outline the purpose of React as a JavaScript library, explain the concept of the React component model, and identify examples of common components. Demonstrate a high-level understanding of React components. Explain how React components operate as a hierarchy in order to generate a web page through the virtual DOM. You're now familiar with the basics of UI frameworks and libraries, and the basics of React and React Native. Excellent! You've made great progress. In this course, you were introduced to the foundations of web development. Let's do a brief recap of what you covered. Module 1 was Get Started with Web Development. In this first module, you learned about the different types of web developers and the roles and responsibilities of front-end, back-end, and full-stack developers. You gained knowledge about the core technologies of HTML, CSS, and JavaScript, and explored the concept of how the internet works. The module also featured an example to show what a day in the life of a web developer is like. Next, you learned more about web pages, web servers, and web browsers, and how they all work together to create what we call the internet. You covered what happens when you send a request to look for something online and how that information gets back to you. Then, you were introduced to core internet technologies and how they interact. You explored some web browser tools that you can use to help you code more efficiently. Finally, you learned what an IDE is and how it can help you speed up your work to write code. An introduction to HTML and CSS followed in Module 2. In Module 2, you learned about HTML and CSS. In HTML, you discovered how to create an HTML document, use simple HTML tags, and link documents to create a website. Then, you learned about the Document Object Model, or DOM, and how it's used to display the content that you see on your device. In addition, you covered techniques to improve web accessibility and some assistive technologies available to provide universal access to the internet. Next, you learned how to use CSS to style web pages. You explored how to select and style elements and use text, color, and alignment to make the web pages you create look great and offer a great user experience. You then used your new HTML and CSS skills together to create a web page. In Module 3, you learned how to use the Bootstrap framework to build responsive interfaces and got to know the benefits of working with UI frameworks. First, you were introduced to the concept of responsive design and working with libraries. Then, you learned how to get started with the Bootstrap library and how to use Bootstrap styles, and you explored some alternative UI frameworks and libraries. Finally, you were introduced to the JavaScript library React. You learned why it was created by meta engineers and how it works at a high level. You then briefly explored the virtual DOM, component hierarchy, and some alternatives to React. Well done on completing this course recap. Now it's time to put into practice all that you've learned in the graded assessment. Are you ready to edit your biographical web page? Good luck. Congratulations on completing the Introduction to Web Development course. You've worked hard to get here and developed a lot of new skills during the course. You should now have a great foundation of front-end web development skills that you can build on. And you've also demonstrated your skill set by editing and styling a web page in the graded assessment. Following completion of the first course, you are now able to describe the web developer job role, distinguish between front-end, back-end, and full-stack developers, explain how data moves through the internet, and describe the technologies that underpin the internet. The key skills measured in the lab showed your ability to use HTML to create a simple web page, use CSS to define the style of a simple web page, outline the concepts that exist in most UI frameworks using Bootstrap as an example to directly reference common practice, and use the Bootstrap CSS framework to create web pages. In addition, you should now have the ability to use Bootstrap documentation to reproduce and modify CSS components, use Bootstrap themes to speed up your workflow, and describe the basics of React in relation to other frameworks and web technologies. So, what are the next steps? Well, this is the first course in the Meta Front-End Developer Professional Certificate. While you've established a good foundation so far, there's still more for you to learn. So if you've enjoyed this course and want to discover more, why not enroll in the second course? Throughout each of these courses, you'll continue to develop your skill set. And in the final assessment, you'll bring together all the skills you've learned and create your own fully functional website. Whether you're just starting out as a technical professional or student, this project will prove your knowledge of the values and capabilities of React. You'll have a functional website to include in your portfolio to demonstrate your skills to potential employers. This shows employers that you are self-driven and innovative. It also speaks volumes about you as an individual and your drive to continue your growth. Once you've completed all the courses in this professional certificate, you'll receive a Coursera certification for Meta Front-End Developer. Meta certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Congratulations once again on reaching the end of this course. It's been a pleasure to embark on this voyage of discovery with you. Best of luck, and do continue to follow your learning journey.